any orange clothes in my closet, so I brought my suitcase. Yeah, and then that's how I managed to put my presence on stage with an orange color. Why orange? Because orange is the color of the Lowlands. Of course, we have it. Okay, let me tell you about the logo. As you can see, the logo tells you a story. It has a blue elephant. You obviously know why the blue elephant is. Okay, good, thank you. The blue elephant is representing Postgres, of course, and you have the national flower. The symbol of the Netherlands is a, who knows it? A tulip, thanks, an orange tulip. So by combining them, you have this beautiful logo of the PGDay Lowlands. If you look at your back, there's going to be two images, the elephant and the tulip, and that's how they combine, and then we get our logo. Good. So, I'll tell you about the logo, and we are going to start. And I want you to see my slides here so that I can tell everybody the same story again, but now with beautiful images. Thank you. All right, PGDay Lowlands, Amsterdam. We do have a song. If you go to Spotify and you search for PGDay Lowlands, you can listen to it. Yeah, we're going to be playing it here. Super good song. I love it. I think if we have a competition who has listened to it the most, I'm probably second, because I know that somebody else listened to it even more than me. If you need Wi-Fi access, you can get it here. I've been practicing 1 month to pronounce this, and I'm not going to get it right. But this is Zwijger Zalen, with an underscore in between the two words. Thank you. And the password is the Zwijger. Okay? Good. Thank you very much. Thank you very much. Now, that's your Wi-Fi information. I mentioned about the code of conduct. It's very similar to the one of Postgres. Now, if you, for some reason, feel uncomfortable, you can talk to any of these three persons, Floor, Jos, and Rita. And I will ask them to stand up, Jos and Rita, who are here nearby. We don't have T-shirts, but we do have a very nice badge thing. So if you don't recognize the picture of the person, you can search for that and you will find them. Good. Thank you, Rita. Thank you, Jos. The good thing is that one of them, Floor, is from the organizing committee. So if you have a problem with the organizing committee, you can contact Jos or Rita. And Jos is our external Code of Conduct committee member who is not even part of any other Postgres conference. So he doesn't have friends here except for me and Floor. So if you have a problem with me and Floor, then you can talk to Rita. Now, he told me that one of his goals for this conference is to have at least 7 friends when he ends up the meeting. So talk to him, please. Good. Now, lanyards, I already explained you. Blue, picture. Red, no picture. And another clap for Megan, who is going to take in your beautiful smiles. We have an organizing committee. I already show you 2 of the members. I'm also part of this organizing committee, a very nice team. We do have pictures from all the meetings that you will see when we put them on the round for the breaks and all this stuff. So we have Dirk, Floor, Nico, Teresa, Thijs, and Sarah Conway, and yours truly. Good? Now, for the program committee, I was assigned to be the furniture of the program committee. Some people call it the chair. So I was not voting, I was just helping the other 4 members, Afsana, Carol, Chris, and Gerard from the user group Netherlands, to select the program. So the program is thanks to them that we're doing a very nice job organizing stuff, giving a good variety of themes and everything that is you're going to be seeing today. That's our program committee, so give applause for them. All right, so we also have all the people who helped us during this process, very important people. We had Karen Jex, who is helping us from the Postgres Europe group. She put an extra effort, so we definitely need to thank her. It was a very important help for us, so we would like to thank her. We also have Dave Pitts, who is here. Can you stand up, please? Because, Karen is not here, but you are here. So he created the song. So if you listen to the song, it is him and Thomas. Yeah, Thomas. Yes, he is Dave and Thomas. We have also Stacy Rastova, if I pronounce that correctly, who is helping us from the organization as well, and also moderating on the channel in the live stream. Paul van Rixel and Feke. I cannot pronounce your family name, Feke, sorry. But they gave us the first booth also when we were organizing in the beginning, and they're also present here. And we also have Vic Ferrin, who was helping us with the badges and also with the live streaming now. And we would like to have a very, very special thank, I don't know, Chris, are you here? Chris Ellis. So Chris Ellis, he was a main person in the whole infrastructure and helping us every day. We are going to give him a prize at the end, but we have given him, in terms of a sir or a knight, the title of the High Lowlander, okay, special prize, and he gets a hat. Thank you, Chris. Right, again, sponsors, and now I'm going to name them because we couldn't do this without them. We have, for the partner sponsors, Kangaroot, Optima Data, EDB, or EDB, Cybertech, and Adyen. Thank you very much. And we also have another level of sponsorship, which is the supporters. We had AWS, Nextteam, Percona, Microsoft, Postgres Experts, and UpCloud. Good. Now, because we also want to help the sponsors a little bit more, we want to have you got the sponsor passport when you arrive? This one, you go with your passport, and then you go to visit the booth, and the people from the sponsor, they are going to give you the partner ones, a stamp on your passport, and then you put your name, you give it to us, and then we are going to be able to give you one of these nice prizes, flowers from Lego, and this one is my favorite one because it's a metal fan, you know, this fan for... It feels like I'm a metal fan as well, so. So you can win one of these, what we are going to give at the end of the conference. Good. Now, this is the program for today, because I cannot pronounce the other word. This is terrible. You cannot see this. So go to the website, and then you go to schedule, program, but spelled in that way, okay? And then you get all the details. Now, a very important rule, in between they are going to have breaks, lunch. We have something called borrowed by the DevOps people, the Pac-Man rule. I think there are all the conferences that use this well. If you look at these boring elephants, they are kind of in a group, and they don't let anybody in. They're just in a close part. But if you know the shape of a Pac-Man has an opening, because it's always kind of eating. So if you are standing there in a group of 4, you always leave room for somebody else, and then if somebody says, oh, this looks like a good bunch of people, like you also want to make some new friends, he will come and he will join. If you close your group, nobody can join the conversation. If you open it, people are going to be able to join your conversation. So try to apply that rule. It's not compulsory, mandatory, but it's a very good idea, I think. All right, good. At the end of the last conference, of the last presentation, the closing stuff, we are going to have a social event here until 9, and then we are going to see where we go to some other places. But that's the last thing that we're going to do for today officially, all right? Good. You can join social. We have also a screen there with the socials, also over there. So if you put anything on the Bird social network, or the Mastodon, which has also an animal that looks like an elephant, but we also have LinkedIn and the YouTube channel PGDay Lowlands, where we are going to put all the presentations separated one by one as soon as we get them available, so that you can watch the recordings after that. But before we get the recordings, we're going to do the live streaming. You're going to give you the URL soon. This is super important. As PGDay Lowlands, we wanted to contribute to the community, not just by doing the event, but also helping people and motivating them to do testing of Postgres 17, because we have now the release candidate 1. Used to be the beta 3, but now we're on release candidate 1 already. And there were some prizes. Nextteam donated a ticket to go here, and then Ed Bangma, which is sitting there, he was the one that was able to get that ticket, so that is not available anymore. For all the people who want to get a physical copy of the PostgreSQL 16 administration cookbook or another elephant, had time until 2 minutes to midnight last night to submit test. So we are also going to raffle that. Now there's no more prizes, physical prizes, but there is also the possibility to appear in the wall of testers. So we are going to have a special page on the PGDay Lowlands website with all the people who tested Postgres 17 until the release. If you test it after the release, well, it's already released. Try to test it before it is released, and we are going to make publicity of you contributing to Postgres. That's it. And this is a live stream. Of course, you can go there now, but I mean, if you're here, you don't have to. I mean, you can watch the whole thing in experience and afterwards. The good thing is that we also have the code of conduct in the chat of the live stream. If you want to comment stuff on the live stream, you can do it. And then we have an online Code of Conduct committee member, which is Sarah Conway, who is from the other side of the world monitoring this stuff. So an applause for Sarah as well, who is helping us from the other. Hey, Sarah, where are you? Sarah, thank you very much. All right, and that's everything for me. You can give feedback for the conference at the same URL with /f, yeah? And then, but if you can give us feedback in person, that's also appreciated. Every talk will have a space for feedback. And we are going to start with the first talk, which is going to be our friend Leticia Avro. Does you know? No? What? Not? Which video? Ah, now a video. Before Leticia, we have a video. And who plays the video? I'm not playing the video, right? I just... So we have a video with music.
PGDay Lowlands celebrates. Oh, we track and chat so great. From devs to users, join the crew. Learn and share, so much to do. PGDay Lowlands Amsterdam. Oh, we track chats, I'll be damned. From devs to users, join the crew. Learn and share, so much to do. PGDay Lowlands celebrates. Oh, we track and chat so great. From devs to users, join the crew. Learn and share, so much to do. PGDay Lowlands Amsterdam. Oh, we track chats, I'll be damned. From devs to users, join the crew. Learn and share, so much to do. Lowlands Amsterdam. Lowlands Amsterdam.
All right, good. So where's the... Thank you. Really enjoyable meetings that we have. As you see, some people were joining from the vacation, some others were joining from the train, so everybody was really engaged in this team, so I really appreciate that. So thank you very much again, Dave, for the music. Really appreciate it. And now I'm going to let you with Leticia Avro, who is, as you know, a very nice chess player. And the reason why we put this talk in the beginning is because she's going to talk about some important things that are controversial, maybe. So it's going to give us a lot of opportunities to talk in the break and at lunch. So that's the idea that is at the beginning. If we put it at the end, everybody's gone and tired. So that's why we are going to start with this talk. And remember to use the Pacman rule, yeah, so that you can allow people for joining the conversation. So please welcome Leticia Avro.
So this is not the kind of talk that I do normally, because the one who knows me knows that I'm very passionate about Postgres. Once I put a message on Twitter saying, "How dare you criticize Postgres?" And Andreas Schenbaum answered, "I don't know who you are, but run fast." So that's not the kind of things I do, but I have to be honest, and there are some pain points in Postgres, but we will see also there is some bad faith from some users, so we'll debunk that. First of all, about my slides, before I was doing regular slides with bullet points, and I found out that people were reading my slides instead of listening to me. I'm a mom. That's very infuriating to be ignored. I already have children to do that for me, so I don't want colleagues and friends to do the same. So I removed all words from my slides. And then I had the feedback that sometimes it's not easy to follow a talk when there's no word. And for whatever reason, you might have hearing disabilities, you might have ADHD or whatever, or you might be distracting today because you're having a bad day or whatever. So what I do is I share here the slides with bullet points. It's not the slides that I will present, but it's the same one, except that there are bullet points on top of it. Also, it's more interesting to share slides with bullet points because sharing only slides with images is not very relevant. So feel free to go here to get the, what I call the annotated slides. About me, so my name is Laetitia Avro. Sorry, I'm French. It's very difficult to say for non-French people. That's life. I'm pretty sure my parents did that on purpose, but whatever. I'm the PostgreSQL Europe treasurer. I'm also the founder of Postgres Women. And I'm working as a practice leader for Postgres and security at EDB. It's a US company, so I have a very, very nice title, but it does not mean anything to people, so I have to explain. What I'm doing is I'm explaining, or I'm the entry point for any question related to Postgres or its security at EDB for customer-facing people, technical customer-facing people. So customer success managers, technical account managers, consultants, remote DBAs, support, and so on. Also, I have a little blog, mydbandnotebook.org, where I try to write things that I want to remember, because, you know, I'm not that young, and sometimes my memory fails me. And also, I launched a thing. I found out that there is no way I can learn if people don't ask their question to me. That's actually my job now. But if you have any question, you can contact me. And then if I might write a blog with the answer, or actually not the truth answer, my answer, because we know that if it was simple, you wouldn't ask the question. So that's another way for me to add blogs to add posts to my blog. And I'm also responsible for this little website. It's not over yet. I have over 100 tips. The final goal is between 200 and 300. So it's only halfway in the best prediction. But what I'm trying to do is to cut PSQL documentation into small tips that you can look when you have some time to spend, you know, when you're in the waiting room for the doctor or things like that. You can just look at some tips to help you with PSQL, because in my opinion, that's the best client ever for Postgres. Forget your GUIs and use the CLI, because that's a really great tool. So let's talk about what we will be talking today. So there are several categories of things that are pain points in Postgres, and I put them into categories I called things that. So you have things that are obvious. Then we will go into things that you don't understand, meaning that Postgres is not our fault. Then we have things that just happen, and things that are complex. And we will finish with things that should be easier. So, about things that are obvious. So, how many people struggled with the name of Postgres? So, this mug was given to me in PGDay Chicago. And actually, there was a display of several mugs. I picked this one, which was the only one misspelled, because it's a collector one. And also, it proved that it was hand-painted. But it means that people outside the community are struggling with the name. And if you know a little about marketing, names and how you name things do matter. So, it's hard to write. Here is examples of what I've seen in my career. So this is the French Postgres, of course. Then I had also Progrès, which is French for progress. I assumed there was some autocorrect here, but who knows. I had the English version, Progress. Of course, the Postgres, whatever. I had PostgreSQL. I had Postgras, which is an insult, because in French it means post-fat. I had Postgre SQL, and I had PostgreSQL. So, when you name a project, be very careful. And then it's impossible to say. It's that impossible that we do have in the wiki how you have to pronounce it. We even created an audio file, so you don't mess up. But guess what? Each time I'm inviting for an interview, podcast, whatever, people ask me, how should I pronounce it? So we have this say, and I don't know if it's targeted for French people, because we do have a lot of mute letters in French, but it's written PostgreSQL, but the Q and the L are mute letters. So it's Postgres. But the problem with that is that we have three names, actually. PostgreSQL, Postgres, and PG for short. We could say that's not a big deal. Everyone knows what we're referring to. The problem is that there are some implications in that. When you're searching the internet, which name will give you the best answers? You don't know. And also, DB engine ranking is based on, well, it's based on several things, but one of them is the internet search for PostgreSQL database and then a question. No one ever did a Google search using PostgreSQL database and what they are looking for. They're using PG, Postgres, or PSQL and what they're looking for. But no one ever will use PostgreSQL database. So that the DB engine ranking for Postgres is wrong, and it's too low compared to what it should be. So that's directly related to the byte choice of the name. Then we have something called an elephant. So the elephant is great. It relates to memory, and when we talk about relational database, we don't want to lose the data, so that's fine. The problem is, it might be a little outdated. So I will go with you into a small dialogue a fictional mother had with her fictional daughter. I will deny having that conversation with my daughter. So the question is, what do you think of the Postgres logo? And the fictional daughter answered, the color is a little insipid, but it's fine. So I insisted, don't you think it feels a little old and outdated? And then she burnt me. Well, it's not a community of youngsters either. Ouch. Yeah, but let's be honest. The logo is outdated, and maybe we could find a way to make it a little better. Because logos is not a thing that you do once and never work on it ever. That's not how it works. So that was the obvious things that are wrong with Postgres. Let's talk about the thing that you don't understand. Normally, Postgres is very good with error messages and will give you an explanation of what's going on, and normally it's accurate. But remember, it's still a stupid algorithm. It's not a human. And stupid algorithms tend to be extremely frustrating to humans when you don't understand them, because there is no other way of asking the question, so it will keep repeating the same things. So you know what we all do? We try again without any change, and we still get the same error message. And we're that stupid that we are surprised about it. So here is an example of stupid error message. So this is a pgdump command with several flags. And we get this error, no matching extensions were found. So what does that mean? Is it talking about extension in my Postgres database? What is it talking about? Actually, the problem is that here it's not the right flag, because if you want to use a word as a flag, you need 2 dashes, not 1. So extension related to flags. maybe not the best choice of word here. Let's see another one that I found on Stack Overflow. So the person is exporting the password, then trying to connect to launch a simple query. So first, let's address that this is totally useful. It's using twice the same flag. But that's the kind of things you will find on Stack Overflow, and people will keep copy-paste that. Because they don't understand anything, but it works there, so I will copy-paste here. And yes, it does not harm anything to have twice the same flag. But it's still not very, very smart. And it says no password supplied. Come on, it's here. I gave it to you. But here you see that you're using sudo, meaning you will clear all the environment variable you had so that the password is not passed. So yeah, again, no password supplies is the right error message, but for a human, it's difficult to understand it, and it's frustrating. That's the kind of thing, when you see that, go out for a walk, and then you will find it. But if you stay in front of your computer, you can spend 4 hours before finding out where's the problem. Let's try something else. This is a function, so regular functions that will return a table of integers. So first, we create a cursor. We create a variable to store text, which will be the query. And then we have an array of text with countries where a majority of people drink tea. England, Turkey, India, Japan, and China. So first, we just initialize the statement. That seems great. Then we will loop over the table. And if it's different from China, then we will add it to the statement with a union. I don't know what happened to China. I don't want to know. Then we will open the cursor with the statement, and we will return the result. So a very simple function. And when we try to launch this function, we will get a syntax error at or near countries with T. That's not very precise, because we use several times this variable in this function. So let's look at it. So we have a reference to that variable line 8, where we define the array, and then we have it here at line 19. Do you know where the error is? Is it on line 8 or on line 18? 8? Raise your hand. No one? 18? Yeah? OK. Yes, that's on line 18. But the problem is not with countries with T. Well, kind of. The problem is it's an array. You can't do a for loop on an array. You need a for each loop. So, yeah. The problem was here, it's an array, but come on, Postgres. You can be smarter than that. You can tell that you have an array, you can have a for loop. You know that, so why don't you say it? This is another problem I encountered while doing advent of code in SQL. So when you do advent of code of SQL, you have to be ready to write huge scripts of SQL, in particular if you're not very skilled with SQL like me, so that I have a 145 lines of SQL, a script of SQL. So when I run it, and it says me there's a problem at line 142 or 43, I'm like, OK, come on, which one? 142 or 43? So, and then it's nice enough to give me the line. So I go, OK, let's go to line 43. It has nothing to do with the line that is underlined in the error message. So let's look at line 142. And nope, not there either. So, no. So I looked at the line that was in the error message, and I found out that, of course, I do copy-paste my code. So I have an occurrence at line 94, and another one at line 119. How come Postgres can't give me the right line? Well, it can give me the right line, but not the right line number. Well, let's say it's kind of my fault because I do comment my code. Oh, you can see it here. There are some comments in my code because I'm also very chatty on my code. So the problem is when you are at that part of Postgres, comments have already been stripped off your code so that the line numbers don't match the line number of your script, and that's a problem. Okay, let's go into things that just happen. And I'm not saying there's nothing we can do about it. I'm just saying that actually that should be a trade-off that you agreed on when you used Postgres. For example, logs. Logs are needed to ensure atomicity. We want to be able to roll back any modification query. And also for isolation purpose. We don't want you to read another transaction's uncommitted data. So that's part of the ACID properties. That's normally something you signed when you read the little lines of using an RDBMS. But people are still upset with logs. And I'm like, yeah, and I'm upset with rains, but it still happened. So what can you do to avoid log? Well, you can go to NoSQL. You can lower down your isolation level. That will lower down the probability of having logs, but the default of isolation level for Postgres is read committed, which is already the lowest level. You can go to DB2 that allow you to read uncommitted data. Or if you still want to keep Postgres because you know that it's very serious about your data, you can make shorter transactions, and you can only use DML. DML is data modification language, inserts, updates, select for update, for example, when you want to write. Because I've seen developers using constantly select for update, even when they just wanted to read. So, of course, they will end up with logs. But it can be even worse. You can have deadlocks. So a deadlock occurs when you have one transaction waiting for another transaction to complete, to be able to complete because there's a lock. But this other transaction is waiting for the first one. So this one is very basic, simple, only 2 transactions involved. There can be any number of transactions involved as long as when you do the graph of who logs who, you end up in a cycle. So the only solution Postgres has to solve this is to kill one of the query and just look if there's still a deadlock. If there is still a deadlock, it will kill another query, and so on, until there's no deadlock. That's brutal, but there's no other way of solving it. So remember that the more you will have logs, the higher the probability you will enter a deadlock situation will be. So again, make shorter transactions so you will have less logs, and the probability you will enter a deadlock situation is lower. Use only DML when you want to write again. Also, there's a little trick that when you update data or when you write data, try to write them always in the same order, so that the probability that you crisscross transactions is lower. And then again, if you're very upset with deadlocks, you can go to NoSQL, you can lower down your isolation level, try DB2 read and commit it, and so on, because you will have fewer logs. So again, but it comes with a drawback. Then we have replication lag. So what do we call replication lag? Let's say you have two hosts, one primary, one replica. The first one is sending the walls, and then the replica has to write the walls. So the walls is for write-ahead logs. That's where all transactions are written. First, to ensure durability on the primary. In case of crash, we won't lose anything. But also to make sure that we can also use that for streaming replication. So what's the point? What do we call lag? A lag is when the replica is working hard but still getting late from the primary. So normally we express the lag, the replication lag, either in number of walls or in minutes. So what can you do? First, there's something called the laws of physics, and information does not flow without any delay. Of course, normally it's fast, but it can't be faster than your network connection. Also, when you apply on the replica host here, so here on the primary, normally you have several threads modifying your data, because that's a life of database. You rarely have only one connection modifying your data. So you have several connections modifying your data here, but then here you have only one process applying your data. So, of course, that can be that can cause a delay. And then I might ask, why is there a delay? Is that a regular delay, or is that something that you observe during peaks? Why is that a problem? Do you want to read from your replica? And so it's a problem because you have a consistency issue. You can perfectly say, OK, I will read from there, but as I want some kind of consistency, it's not perfect consistency, I will use synchronous replication. It means that lag, instead of being between the primary and the replica, it will be between the application and the primary, because we will have to wait for the primary to say, OK, the replica has applied my changes, so it's safe, and I can send the acknowledgement to the application. So you will change the lag. Instead of being between both databases host, it will be between the database and the application. And there's no way to remove it. Again, laws of physics. And also, we have a nice theorem called the Pakhuis theorem. It's an evolution of the CAP theorem that you might know. It states that in case of network partitioning, you have to choose between favoring availability or consistency. But else, even though there's no network partitioning, you will still have to choose between latency and consistency. So go search the Pakhuis theorem if you don't know it, but still, you will have some latency somewhere. So maybe your architecture is not right, and you want to go to synchronous replication. Maybe your problem is not that you need to go to synchronous replication. Maybe the reads you're doing on your replica is more a no-lap kind of workload where you have OLTP on the primary. In that case, maybe physical streaming replication is not the right choice for you, and you should have chosen something like logical replication, and so on. So first, yeah, do think about your architecture and why it's a problem that of replication lag. If it's constant, then you do have a problem, I agree. But maybe you should buy more CPUs, more RAM. I don't know if you've seen, but AMD will release new CPUs in December. And they have amazing capability, over 300 threads per CPU. So, and you can have servers with 10 terabytes of RAM. So maybe the problem is that you're running on cheap hardware and you need something more. Maybe, I don't know. It really depends on what you're doing. So, OK, let's go to things that are complex. And I put that picture because we all know that when it's complex, we just wish that it works. Well, not always. So, OK, let's go into something bad. OK, so I said that Postgres is good with isolation and atomicity so that it can roll back data. To do that, we decided, well, the project decided back in the 90s to do in-place changes. And to do that, instead of deleting physically a row or updating physically a row, what we do is a soft delete and a soft update, well, a soft deletion and insertion when we update, so that we say that this row was created by that transaction number, and all transactions that came before can't see it. Only transactions that came after can see them, and so on. I'm simplifying because I could talk for hours about XID wraparound. But what you need to know is we're in IT, and in IT there's nothing like an infinite number. So that we decided in the 90s that over 2 billion of transactions should be good enough, so we put an integer in it. But nowadays, an integer is not that good, and we can find ourselves in situations where we will wrap around the circle of numbers, and we will corrupt the whole cluster, which is bad and dangerous. Just remember that at the time, in the 90s, Oracle had chosen something different, and this something different is called the undo table space, where they store the previous versions of rows. And who's been hit by the snapshot to old error? Yeah, we know that. So it was not a perfect solution either. So just so you know, there was a project led by ADB at the time. It was called zheap. Why zheap? Because everything is cooler and classier with a Z. Yeah, that's what they told me. But the main point was to change how we well, it's a huge project, but it was abandoned by ADB because it was it's very complex and difficult. I know Cybertech took it and did some commits in Postgres to help the heap move forward, but we are not there yet. So just remember that that's something that can happen. So to prevent any XID wraparound, what we do is from time to time, we go through the XID, the transactions numbers, and we freeze them. A frozen XID is a special number that is lower to any other, so that from that point, we can keep going and we won't have an XID wraparound. And also, the other problem, if you keep adding data to your database with soft deletion and soft update, then at one point you will be out of space, even though no one can read these old transactions, those dead rows. No one can read them, but it's there. So we're creating something called vacuum. Yay! So it will, well, it's called remove dead rows. It won't give back any storage space. It will only mark as dead some spaces so that it can be reused. So that's what vacuum does. And again, you will see how the Postgres project is good with naming things. So there is an operation called vacuum analyze. It vacuums and analyzes. analyzing is just gathering statistics, okay? So vacuum analyze means vacuum plus analyze. Great. Vacuum freeze will vacuum and freeze, so create this frozen XID for the ancient rows that needs to keep being there but are ancient. And then we have vacuum full. It doesn't vacuum plus full. It wouldn't say anything. Actually, vacuum full is a totally different process than vacuum. It will rewrite your whole tables, which might not be what you want. Vacuum full is more like that, if you're old enough to understand. So yeah, that's kind of a defrag of your tables. Why people do hate vacuum? Because it takes resources, and that's true. But remember that vacuum is necessary. Postgres being as nice as it is, should you want to shoot yourself in the foot, Postgres will make sure the bullet enters your foot in the perfect angle to make sure it makes the more damages. So you can deactivate auto vacuum if you want, but it comes with a price. So we have a saying in the Postgres community. It's that if vacuum hurts, well, when we say vacuum, most of the time nowadays we talk about the auto vacuum daemon. So if auto vacuum hurts, it's like sport. It's when, you know, the first time you do sports after having for 10 years being a potato coach, you might be sore the next day. Does it mean you have to stop and quit sports? It might mean that you're not doing it frequently enough. Same thing with auto vacuum. If it hurts, you're not doing it frequently enough. And why that? Because the stupid default values of auto vacuum. And why that? Because we decided that Postgres should run even on a Raspberry Pi first generation. We have no idea on what you will be running it. But what we know is we don't want it to fail, because stability is really important to the Postgres project. So that we will make it run, but we will prevent it to run smoothly. So whatever you do, if you install a fresh cluster, don't use a configuration out of the box and tune it. And also, it's very difficult to find the best values, because well, best values has to be related to at the time. So it will change over time. That's the first thing. And second, we don't know your workload. We don't know what you will be doing with Postgres. Postgres is generalist. It can do a lot of things. So you have to figure it out. We have good starting points in the community that we know, that we share, but you will have to figure it out for your own cluster. And then we have collation, so I'm not talking about small snacks. I'm talking about how we will sort text data. So collations depend on glibc in Postgres. And that's a problem, because your glibc is embedded inside your operating system. And should you change your major version operating system or decide to go from whatever, Red Hat to Ubuntu or whatever you want, you might corrupt your indexes or your data, which is not nice. So we try to make it better. Now we have, in Postgres 17, we have an internal collation. We also have information about the collation that is used for your data, so that at least you might know that there might be a problem with your grade, your subgrade or whatever. And yeah, Jeremy will talk about that this afternoon, because he will be talking about production nightmares, and that's one of them. OK, there are things that should be easier in Postgres. Have you ever run 50+ lines queries just to do simple administrative tasks in Postgres? No more than that? OK. Well, This is a script taken from a PGX script. I really encourage you to go there if you don't know that GitHub repo. It's a gold mine. So this script is meant to give information about index bloat. Do you know how many lines in this script? Who think it's a 10-line script? Yeah, no, it's already more than 10. 20? Who thinks it's 20? 50? Over 100? Over 200? Over 300? No, it's 101. Oh. But come on, it should be easier to get bloat information, because that's a major problem of Postgres. We do know it, so we should have a convenient way to provide this information. Okay, this one, I love it. So it's another bloat query to gather the bloat information from tables. But look at this comment. Is often off by plus or minus 20%. So it's an estimate. By the way, the previous one was also an estimate. How many lines in that script? OK, let's over 100? Over 200? 300? No, it's 140, but already impressive just to gather bloat information. So if you want a patch ID, I want a system administration function to gather bloat estimates. It does not have to be accurate to exactly the value. An estimate is fine enough, but it is fine, but it has to be close enough. Here is another script. If you want to see all the permissions a user have, including the one he has by being granting another role and so on, then how many lines of SQL will you have to run to do that? More than 50? 177, just to gather that information. Yeah. So again, that's the kind of thing that could be easier. And again, I'd like to see an administration function to have this information. And we could also add it to the meta command of PSQL \du. And then we've all been there when you have to do major upgrade. So major upgrades by themselves are not that tricky. The problem is when you're using extensions and when you have a very, very tiny maintenance window, then you have a problem. But you know that Postgres rely on an internal catalog called the PG, that you can query, actually, in the schema, PG catalog. And between major versions, this catalog can change. And there's no other way than using PG upgrade to or logical export and reimport to have your data be compliant with the next major version. So that's a flexibility the project wants to keep, but the project is nice enough to support 5 major versions. I haven't seen any other project supporting that many major versions. So please do it. You have each time 5 years to upgrade. I wouldn't recommend to upgrade to Postgres 12 now. Obviously, I would recommend to go to 17. But do what you can also with the resources you have. But don't run on an old version. And the next one I want to be improved is partitioning. There is no automatic creation of the new partitions, especially for time series. That's something we could create. People will tell me there is a PG Partman extension, but why can't Postgres do it? It seems like only half of the job has been done. So we could get better on that. So it's time to conclude. Just to make it right, Postgres is good. I'm not saying you shouldn't use Postgres. Postgres is really good. Sometimes I've seen the problem is the user of Postgres, which is fine because sometimes, well, who does read all the small lines in the contract before signing it? No one. So it's OK. But there also are some real pains that we would like to solve in Postgres. So if you're feeling like you can help, you're welcome to come and help. If you're feeling that you can't help, that's not true. You can. And so I will take a few questions if there are.
Thank you very much, Leticia. So we have time for one question. If we have, I want that to be a question, not a comment, because for comments we have the break, and in the break you can talk with Leticia and with everybody about this kind of stuff. So we have one question here.
Is there any of these examples that you have been personally burned with?
The logo one? Actually, I'm a consultant. I was a consultant for a long time. I have no production. I've seen it at my customers, but it's not my babies. But still hurts.
Okay, good. So again, a round of applause for Leticia. Thank you very much. Right, so we start getting ready for our next speaker, who is going to come in a few seconds here on stage. And after that speaker, we are going to have a nice break where you can have your refreshment, visit the sponsors, get your stamp on your passport, and then we're all going to be having a nice closing session with nice prizes, the metal fan, and the beautiful flowers there. Our next speaker is a known speaker from the community as Leticia, so both of them you have seen them in the circuits of Postgres conferences. And he's going to be telling us very nice story that he was telling us yesterday. By the way, he's not wearing either the blue or the red lanyard, but he's having some blue on his lanyard, so he's allowed you to take a picture of him, right? We can take all pictures that we want from you. Okay, right, excellent. Want to use your own? Okay.
This could go over.
No, it doesn't matter. You take 45 minutes. You use your 45 minutes. Right, for the people who is following the live stream, feel free to make your comments there. If you want to, from here, from the room, also do comments, you can do it in the YouTube part when you have the live stream, or use the social media where we have there so you can join the conversation. Okay, so there's going to be also some social media following there on the other screen if you don't want to open your mobile phone because you want to pay attention to everything that our friend Pablo is going to tell us. All right, so you're almost ready with everything? No? We go do it again. Who have seen already Pablo before in another conference? Okay, so you see, it's a known fellow from the conference. You have your slides there, so it should be there.
Yeah, I will try to.
There you go.
This one. Yeah, but I cannot see how to start it. Okay, so, yeah, and yeah. Okay.
Now you need full screen.
F11.
All right, so please welcome Pablo Golub.
Hello there. Where's my mouse? Okay, cool. First of all, how many of you know about the game Wordle? Okay, good, we can go. So, my name is Pavlo Golub. I'm from Cybertech, and I'm kind of senior man, whatever, consultant and developer, I do things, you know. So, Cybertech is very Postgres company. To be our client, you need to have one I mean Postgres. If you don't have one, we can run it for you, and then you can become our client. So we have like several branches, and we are working on extending. These are our commercial products. You can try them. You all know why Postgres is the best database in the world. And agenda for today. So, first of all, some fun facts about the game. Then I will describe how we can improve it in PostgreSQL, changing some words or comparison functions. And at the end of the session, we will play with you, and we will see how you know Postgres reserved keywords. OK, so history and facts. So nothing like, usual game, classic 5-guess challenge. You have a word, you need to guess it. What is the catch? When you guess the word, the game will give you a hint by colorizing your input. If you get the letter correctly, it will become green. If there is a letter but the position is wrong, it will become yellow. That's all. How it looks like, right? Now, the story behind this. So, the Josh Wardle is a developer of the Wordle game. He lived in Brooklyn, and he said that he created this game for his partner. Love, you know. That's why I like to be a developer, you know, programmer, because instead of writing poems, you can write a program. Once I wrote a game for my mom back in my 20s. Why? Because she spent a lot of time on modem holding the line. So I wrote the same game so she can play locally. OK, so the game was there like for a long time. Why 2020? You know why? Because of COVID. We all were like on the same boat. We were like looking for what else we can do at home. And why Wordle became so famous? So the Josh himself thinks that because of 3 things. First one is the scarcity. So the only one word, only one game per day. It's simple. So you don't need nothing. You can play from your phone or laptop or any browser you have. And the limited commitment. So no advertising, no notification, no strings attached, right? But we all know it became viral. On every social media, especially on Twitter, there were a lot of tweets with these unknown things like, what? Green, yellow, what's going on? And that's how I knew about it. So it's just like, I started to Google what these green and yellow squares in Twitter. And so, oh, this is the game. And I found it. So this is my best attempt. It took only 2 guesses. And the first one was total miss. But the second one was like, I did it. So how many Wordles are there in the world? A lot. I mean, the game is simple. The idea behind it is very simple, so you can go like for anything. Like, for example, you can change word set, or you can change how you compare the words, or you can guess several words at once, or you can, you can change how you enter your guesses, like changing the letters or something like this. Okay. And of course, every country, every language wanted to have their own. A lot of them, like 350, maybe more, I don't know. So, for example, the last one is Swordle. This is not language, but I mean, you know. I swear a lot in my local language, in my native language, but I'm not swearing in English because, like, I don't know, don't know the words. So probably I should play the game to know more. And the teams, you can guess airports, birds, animals, Star Trek, the office, whatever. The last one, the hexadecimal, is where you need to guess the number by its hexadecimal representation. Okay, so before we go into it, I'm, by the way, a teacher of mathematics and computer science. So I decided to put it into level. So I need a mathematical definition of the game of Wordle. Here it is. So the Wordle is a combination of two sets and a function, where first set, Wn, is a set of n-letter function, and the length of these words should be positive, so no empty strings, right? And Gn, a set of guesses, and guesses, the set of guesses should be a subset of words, okay, right? And the delta is a distant function. So for every word that we can guess, and for every word we can set as an input, there should be a value for this function, which is d. D is a set which, of course, should have a 0. 0 indicates that you are correct, that you found your guess. And anything else, but with the order. So the basic example, the integer set, 0 is you're doing right. The bigger the number, the more like you're missing. Or you can use strings as well, because on strings we can define the order. And of course, for every word we can guess, there must exist the answer. And the value of this function should be 0. Okay, so let's go, for example, PostgreSQL. Sounds like a volcano in Iceland, right? PostgreSQL. Okay, so where can we have some words? We have PG get keywords function, which returns a lot of keywords from the server, and turned out that like there are 65 of them, of lengths of 5. It's enough to start, right? Let's go with it. So so the idea was to implement all this game in pure SQL. No PGDay, no external, whatever, just SQL and PSQL as a terminal. So first of all, how can we check the two words, for example, types and table? Pretty easy. First of all, we can split the string into a table. So each letter goes to its own row. Then we can compare them. Green one if they are the same, blue or yellow one if there is a position in the string, and the black one otherwise. Very simple, okay? We have one. Now, let's use this knowledge and create a SQL function for that so we can use it in our game. So the only difference here is I added string egg, which will combine all the rows back to the string, right? So yeah, let's find all the keywords that are common to word types. And we order by the D, which is not distance, but should be like similarity. So okay, of course, types is very similar to types. Table, treat, blah, 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 whatever. Can you see a problem here? Where? Okay. Yes, that's true. The thing is that we are sorting by the alphabet, by the string sorting. But there are for sure like more words that are similar to types than, for example, outer. Let's try to fix that. And to fix that, we okay, so anyway, this query has its own flow because it doubles the owner and owned, the valid and the value, etc., etc. So we need to get rid of it. For this, I want to come with the function Wordle command int, mean integer, which will return the similarity, right? So instead of going green, yellow, and black boxes, I will assign 2 points for the same letter, 1 point for the letter in the word, and 0 otherwise. So if like 2 words are identical, we have similarity of 10, and then lower, lower, lower. And if they are completely different, the similarity will be 0. Okay, and let's try to use this function, and we have much better results. Because now we are not sorting by the string value, but we are sorting by the integer value, which shows us the similarity. Okay, so we have like at least 3 keywords that are very similar, just 1 letter is different. Let's find more similar words, the same but with larger result set. Now let's speak about word sets. I mean, having keywords from Postgres is fine, is fun, but you only have like 35 of them, or 65 of them. It will like for only 2 months. I want much more. So where can we get one? The first and the obvious is prepare dictionaries and vocabularies. Or we can use the linguist's work and have a text corpuses. Or we can ask artificial intelligence. I went to the ChatGPT, and can you compose a text file with the blah, 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 5 letters words, most, please, and provide me link to download. I'm sorry for any confusion, but I cannot generate. Here's the 20 words, you can use them. Okay, let's go for Bart. Can you please, the same question. Bart is smarter. I saw somewhere, prepared list, here's the link, use it, and download and use it. Okay, the Bing for Microsoft, the best one. Hello, this is Bing. I'm sorry, but I cannot compose a text file for you. That is beyond my capabilities. I can only generate content such as poems, stories, code, essays, songs, celebrity parodies. Thank you, Bing. But as usual, Postgres has it all. Most of it. We have dictionaries inside PostgreSQL. So first of all, let's examine the shared dir of the PostgreSQL. And here we can have tsearch_data, where everything related to text search is stored. So my machine at that time was Ubuntu. And by default, I already have a United States English dictionary. But for example, if you have another locale, probably you will have another dictionary by default. And we have a lot of other files here. So let's check what the dictionaries are. So it's just a link somewhere to cache. Okay, we will see why is that later. So let's check what the dictionary is. Is it just a set of lists with some number on the first line? And probably this is the number of rows, right? And then we have a lot of words in the initial form, and then kind of specific information. Okay, so we can use a spell utility to know what are those files and what these suffixes mean. They tell the dictionary how to produce different form of words from the initial one. So, for example, English is not rich enough for that kind of, but I mean, Slavic languages are very chatty. You can produce like 20 forms from the initial word, for example. Okay, we don't know that. We don't need that because, like, for our goal, we want to use initial form and only 5 letters, right? So, how many 5 letters words we have in in English US dictionary? 6,700. Well, enough, I would say. So, remember I said that I want to use only SQL to get these things. So my first approach would, okay, let's copy everything from a file, and I specify delimiter, which is dash, slash, whatever, slash, yeah. And I want to exclude the first row with the number of words, and I specify the file, and I get error. Why? Because sometimes some words don't have the modifier. For example, I don't know, if some imported word from another language, it will just stay at the same form. Okay, but copy can use program, and here I want to use grep. I want to find only words from this and this, and this and this. Yes, we got it. Next. It turned out that some words somehow have the same initial form. So, for example, for 6,007 whatever, 100, we have only 6,600 unique words. I don't want to have these duplicates, right? Because when you will try to guess them, some words will be chosen more frequently. I want to get rid of them. Okay, so truncate. And do the same with the sort. And U means unique, probably. I don't know. Yeah, cool. Now, what do we have here? So, English, not very chatty, right? Most words are like 7, 8, 9 letter lengths. Okay, good. But then I just like, what the hell is going on here? Only one word, 25, 27, 30. I need to check those. Oh, that was fun. I spent like a whole day trying to read them out. That was fun. Especially these guy. These guy, okay. And then I tried to Google it. So this is not a real word, but invented for some kind of contest or whatever. But how many people know how to read these things? This is called IPA, it's the International Phonetic Alphabet. Yeah, so I believe that most like American and English people have no idea it exists. But in school, we learn this. But anyway, Newman of the macrosiliconicus. Yes. What about other languages? We can install, if you're on Ubuntu or Red Hat, you can install with your package manager. You can download them directly and put to the directory of Postgres. Or there is even a special script, which I will show how it works. So package manager is the simplest one. So for example, I'm using Ubuntu, right? So apt install handspell farm in French. Okay, we are going, go. And here, Devrim, is for you. processing triggers for PostgreSQL common, building dictionaries from installed. That's how they do it. Okay, so after that we will have like a FAR-dict French dictionary in our research data. You can download directly. There are even more sources where you can do that, but these are like the most truthful. So yeah, this is how one can download from Ukrainian language, for example. So UK UA means Ukrainian language for the country UA, right? So okay, so we download it, we put it into the table. You can see this Slavic language is way more chatty than the English. So we have like a lot of 10 plus words. I mean, there are like 200 of them which are longer than 23. The trick is here that we can combine several words into one, just like in German. So like we can go for 50 words, 50 letters without problem. Okay, so special script. So it's not enough to download the dictionary. You want to use it in your PostgreSQL, and for that, you need to create some PostgreSQL objects inside of it. That's how this script can help you. So yeah, first of all, you download the script itself, then you like execute it. So you specify the language code, the country code, and the name of the language. I'm not sure why it's so chatty, but I mean, it's how it was. So and then it will download the dictionaries and stop words and everything you need to have and put it into the proper folder of PostgreSQL. And at the end of the execution, it will provide you with the ready SQL script how you can create a dictionary in your PostgreSQL database. So you don't need to anything, just copy-paste. So yeah, we'll use Spanish handspell, the template is this, the file is this, that and that, configuration, mapping, whatever, blah, blah, blah. Everything there. You may edit, alter it for your needs and use it immediately. So for every new dictionary you will install, you'll have it. Yeah, so, okay, Spanish, not bad. More like English, right? Okay, so comparison functions. Dictionary is good. Now we need to compare the word and our guess and to provide with the result. So for that, it's better to use the distance function. So before that, in my slides, I used the similarity function, which will give you like 10 for similar words and 0 for completely different. But when you operate on this level, you want to distance, and distance is like yeah, so 1 divided by similarity. Right? So let's implement the standard Wordle function. It will, first of all, return distance for calculations, but it will return the description hint to be presented in the UI during our game for people, right? So nothing new here. So twice the length of word, which is 10, minus similarity, and then, well, we saw this already, right? Just implement it as a function. And yeah, let's try to see which keywords are most similar, but with using by the distance function. So owner in owned, in out and input, alter after, etc. But we're not that simple, right? We have more in PostgreSQL. we have n-gram-based compared 3 gram. We have 3 grams implemented and available, but we can add any n-grams function. And from my point of view, the big grams are the best. So this is the general function get n-grams. It will split the word, it will split the strings into the number of n-grams. We will add space before and space after, so we can count the first and the last letter. So let's see how we can split beast and steam into the d-grams or big grams, I don't know. Just like, okay? And then, how we can compare how we can came with the distance measure for these n-grams? Well, it's really simple. The number of n-grams divided by the number of jar lengths. Okay, so count, it means like the common number of n-grams divided by the length, and plus 2 means for d-grams, if the 3 grams plus 3, etc., etc. And we have like the regular float number. Yeah, so this is like the fancy implementation of bgrams. And the world of bgrams will return the integer, or yeah, the integer, and this will be our tip for the user. Now, we don't return the colored boxes because we use different function. Now we return the d-grams that are there in the word, and you need to guess what it is. Okay, so just like that, let's check how many, let's check how many similar keywords we have, but using with the d-grams function. So for example, I try to play it. It's very hard to understand that O and O and WN is owner. I mean, later when you just Control-C and check the debugging, you can say it, but otherwise it's very hard. Okay, so we did it. Fuzzy string match comparison function. We have a special extension in PostgreSQL, fuzzy string match. It comes with several functions for comparison strings, but not for strict comparison, but based on some fancy algorithms. The soundex, metaphone, double metaphone, and Levenstein. Soundex and metaphone are made for English mostly, so they are unusable for other languages. But Levenstein is a good one because it operates on the number of changes you need to apply to a word to make the target word. So how many times I need to replace this letter with another or push it to another position. So the number of moves you need to do is the Levenstein distance. Okay, so let's implement something. So first of all, I want to know how different keywords using the soundex, metaphone, and Levenstein. By the way, the difference function in Levenstein or soundex, which it has a bad name. So it should be like similarity instead. That's why 4 minus difference. So yeah, that's how so for each word, we have a soundex representation, or we have a metaphone representation, and then we can calculate the difference. If you use like the only soundex on the only metaphone, or only Levenstein, it's nearly impossible to guess what the word is. But we can use all 3 at the same time to ease our life. So let's create a new function, wordle fuzzy, that will return integer and will return a guess, a tip, a tip for us, and the tip will contain and SoundX, and Metaphone, and Liebenstein. And having all these 3 different measurements, we can try to guess what we are looking for. Just like that. Close and class. For example, Liebenstein difference is 2, meaning you need to replace O to A and E to S. Gives you 2. But for example, for Metaphone, the difference is 0, because in Metaphone representation, close and class are the same, KLC. That's why English only. Okay, so let's try. Let's try to play. I have a repo. You saw the link to it. So I implemented a Docker Compose file, which will use the custom Docker image with pre-installed dictionaries. For a moment, we have English, French, Dutch. I added just this night. And Ukrainian, yes. So if you want to put some more, just make a pull request. So I have, can you see? Oh, I need to switch, sorry. Duplicate. Oh, can you see it? Cool, cool, cool. So DC is a Docker Compose. I'm very lazy. So DC is alias for Docker Compose, yeah. Okay, so first of all, we want to up our image with pre-installed everything. So D means detach. So we want to play from our terminal, and it will work on background. And force recreate, I want to be sure that every time I start this image, everything is wiped and started all over again, right? So every volume, I don't need them. Just work, please. Okay, it works. We can see some logs. Cool. So you can see here that we download some dictionaries. So we create some distance functions, etc., etc. So we are good to go. Now we can run our PSQL. PSQL is like well-known terminal to work with the Postgres, but can you see it? It's updated. So now, when we are tired, we can play. Let's try. Wordle, it says, right? Whew. Can you see it? The pink menu. I spent the day to find the codes. Okay, so by default, we will play with the Postgres keywords. By default, we will use the standard Wordle function. And yeah, let's do it. B, go. Type your guess and press enter. Okay, what is your guess? What? Begin. Okay, good one. Let's begin with begin. Begin. Ooh. Good one. So we had one move. Our guess was begin. Distance is 7, which is pretty good. And the tip is, so at least 3 letters are there, but we need to know where and which. Now remember, we are speaking about 65 options here, 65 keywords with the length of 5. So, your guesses? Index. Well, okay, let's go for index. It's just a demo. Range. Rage. Whoa! Who was that? Wow, bravo, Jenny. We played yesterday with one of the member of SQL committee, you know, and we spent like 10 moves to do. Okay. Okay. Want another one? Okay, press enter to continue. So, B. What? Month? I didn't know it's a reserved keyword. No. Next month. Any other? Index. Good one. I and E are there. I and E. Becky. No. What? Oh, yeah. I and E. What do you give me? Usually when I play this, I open the terminal. PG get keywords like. Okay, so, I mean, yeah, I know, it's hard. Let's cheat. The word that the game is like guessed, it is there. We just need to find it. Is what we use. I mean, for this level of difficulty, it's fine. We can find the views anyway, right? But if you're playing Dutch on English keyboard without knowing any language, I mean Dutch, then it becomes really cool. So let's try with something different. So for example, oh, okay. So let me show you. So we have such tables here. So the moves one is temporary one. It will recreate every session. So and every others are holding the dictionary of our world. So FR for French and R for Dutch and etc. etc. Let's try to play for Dutch. So we can change the word set and we specify the table NL. Okay, we can start. And now we need to put something. Begin. There is a word begin in that? Wow! Okay. No. Hello? H-A-L-L-O. Okay, always there. Order. Order. Nah. Morgan. M-O-L-E-N. Molen. Woo! By the way, this version is more complicated if the language have diacritics. You need to specify it. So if you want to improve it and use unaccent extensions, please be my guest. Oof. How? V-O-C-H. Vocht. Okay, let's see, what was it? Kokos. Very, very Dutch word. Okay, so one more time, I will show you how to use another function, just how it looks like. We need to, where this function, we want world fuzzy, copy, go here. Okay, so we are playing Postgres keywords, but with the different function. Alter, let me start. And this is our tip. This is our tip. So the distance here is the sum of all distances. So the lower the distance is, the closer we to the source word. Yeah. So pay attention, the Levenstein difference is higher, then we are going the count. Nah. Table. Oh! Johnny, you are the best. You need to go everywhere and present with me.
I watch a film where they suggest to learn the word table when you visit the US.
Okay. So, okay, we have 3 more minutes. You can find everything is following these links. And if you have any questions, please go for it.
Thank you very much. We have time for one question. If somebody has one question, we can take it. Otherwise, I would like also to invite Leticia on stage because we do have a very nice present for the speakers. I'm going to show you here. We call it the EEE because the Epic Electric Elephant, also something made by Chris Ellis. So here you have one for Leticia. And okay, and one for Pablo. So thank you very much to the 2 of them. We're going to have, we're running a little bit late, but we don't want to rush the break because everybody needs a good break and a good pause. So we have 15 minutes for a break. So we are going to be back here on 10 past 11. 11.
11.
11.
11.
10 past 11. See you back here. Thank you very much.
wasn't sure. I just wanted to cover. Another guy who is not tall as I am, but a little bit lower.
Two things quickly before we start.
I need to get this one to sign. You can come back.
Okay.
Maybe I can come back at the end of the or Nick, Gary, like the remote database.
The two things I wanted to say were when you shot each other. When I said back, I said good. It's like this is both facing. Also, I named it. We were doing something to stay in the mind. So just when you shoot me, just say David's dead. And when I shoot you, I'll say Dirk is dead. And it will just like good. The simplest, yeah. So, well, the laptop will be there. We have 5 files. I was thinking you should put them together, or
Yeah, we can put cards.
I mean, we could potentially. I don't want to move them in the thing, but let's move them a bit closer. So initially,
Oh, where did you put the lanyard that I gave you? Because I forgot to remove the pin. You just throw it there?
No, I didn't have it. You were wearing nothing when I
gave you.
No, you didn't.
I took it out and
on
put
the
it here.
table.
Good. Thank you. Yeah. So let me see.
So do we thank Chris before we start? Or?
No. Do you have 45 minutes for your talk or not?
We can probably do it in 42.
No. Then don't take time from your talk to do that.
We don't really need the 45 minutes, right?
I think it's about 40, 35, 40.
Yeah. So we can get some time to.
And I'm not sure if the talk was really needs much Q&A.
Okay. Yeah.
I mean, maybe people will ask, but I mean,
No, because we want to thank Chris, but I mean we can do it at the close and stuff. Up to you, Dirk. I don't want to take time from your talk to do that, you know.
I'm just like more ones down there just to stay aside. Well, no, because initially we have 2 days really quite close, and then we're going to try it slightly further apart.
Okay.
And I'll have to get my stick to walk across just to labour the point.
So this could also be remote DC.
Yeah, absolutely. Are you using the? I mean, also at that point, you've done the whole presentation. Along the last thing, you'll close your laptop. Yeah, I mean, you might lose the screen, but 5 slides, or the first 3 slides in a minute, and then it's like we only change. We go through 3 scenarios: standalone, async, and sync. So
I'm really curious about your talk. Okay, have 7 minutes. I need to go to the toilet.
I need to go. I need to get coffee. I still haven't.
I will bring you coffee.
Which one do you want? Just this one or Americano? So where do we start? There? Where do we start? I think it makes sense to start here in the database. Yes. I start here. I will be here. I mean, yeah.
Now we have lots of space. Get this out of sight somehow. That's out of here, out of sight.
Thank you very much. That's my input. Yours is the orange one there. Okay. Because I'm sort of thinking you're.
Yeah.
If you do the intro, like you start talking, then you hand over to.
Where do we hide these?
You start talking.
They say that they are not going to have many questions, but then you can pick up. No, I'll pick up the yellow one. No, pick up the red one. The red one I'm using to introduce, and they know.
Okay, I think we are a bit over time already. Let's start. I hope you enjoyed the cake during the break. I tasted one, it was really nice. So welcome back. And our next speakers, I actually know them pretty well. I am fortunate enough to work with both of them. So it's Dave Pitts and Dirk van Veen, and they will talk about Postgres high availability. So welcome with a round of applause, please. Thank you.
You're supposed to wear mics, I guess, for the recording. We completely forgot about mics.
There is another.
Yeah, but it's going to be troublesome because we will need our hands. But I guess that's, well, we will figure it out.
Is this mic? This mic is working. Okay, cool. Right, we're going to talk about Postgres high availability. We'll start off with a very quick introduction to us. I'm Dave. I work with my colleague Dirk. I used to be based in Amsterdam for 12 years, living next door, so it's very special to be back at Pakhuis de Zwijger, but I was literally 11 years next door to here. I'm now in Spain, but we still work together. So Dirk, over to you to introduce yourself a little bit.
Yeah, I think everybody knows me for playing chess on conferences, so that's what I do. I look for an excuse to be around all of you, and sometimes you have to say something on stage, so you can go to a lot of conferences and then play a lot of chess with a lot of people. So that's me.
Okay, so let's start on the on getting going. So I'll come over there. So
it's helping you out.
It is. It's tricky. I've hurt my leg, and this is a presentation with a lot of moving parts, and we have microphones to hold. Anyway, so this whole presentation started off from a slightly painful discussion we had, and one of our team was saying, "You'll never get the devs to understand this." And me and Dirk were saying, they need to understand this. How can we communicate this better? So this is our attempt to solve the problem of explaining the various replication choices you have to make. So we're going to talk about standalone, asynchronous, and synchronous replication. And they're valid choices for different scenarios, and the devs need to understand some of those choices. So we're demoing it with cards. We're not playing poker, but we are playing tricks. Some cards will go missing. Some cards will be visible, and they're not visible, and there'll be all sorts of fun and games like that. So shall we start with the actual concepts we want to get across? So Dirk, you were going to talk about RPO, RTO, and failovers, switches.
Yeah, it's one of these things you have to talk about with developers. Usually the conversation starts with, what do you need? Well, I need a database which can grow infinitely. It's never down. What were the other requirements? They are very fast. No matter what you ask. No, they never ask about cheap. They don't pay for them. Our manager complains about the price, but the developers, they never complain about what the database costs. And then we try to tell them, like, it's not magic. There's actually data transport involved. And
I think there's just one other thing they always ask, well, they're asking more and more, is like this data has to be globally accessed. So there has to be the same data everywhere in the same world, instantly.
Forever and ever.
Forever and ever.
Yeah, forever and ever.
Not hard.
Yeah, and then we try to explain, like, it's not magic. There are moving parts involved, and all the data are stored on a server, and sometimes the server actually, something happens. We lose a memory card, the CPU burns, we lose power in the data center, and then we have to use another database in another data center. So sometimes this is planned, so we do a switch over. We prepare nicely, multiple DBAs are watching the process, and the primary database goes from one data center to the other data center. That's okay. Sometimes, in the middle of the night usually, something happens unexpectedly, and then it's like, crap, I'm the only DBA on duty, I'm fixing this right now, I don't care about the devs. And then the day after they get slightly mad at you. And then you have to talk about, well, this has to happen. We told you when you requested the database, but then you didn't care. But I told you. And now it actually happened, and now it's my problem? That feels weird. And then we talk about, did we lose data? How much time was the database offline? So this is the RPO. What is the recovery point objective? How much data did we lose in the process? And on the other side, the devs also care about, it's the RTO, the recovery time objective. How much time did it actually take to get the database back online?
Okay, so those are the initial conversations we have with our devs. Now, to understand the presentation, I want to talk a little bit about database internals and data files and different types of data files. So, very simply, the two databases I know very well are Oracle and Postgres. I've worked with both for over a decade, so I know, and they're very similar in many, many ways. And at this level, they are very similar. You have the heap, which is where all your data is, and your indexes, and your data is sort of just higgledy-piggledy spread, and it's not meant to be accessed in a neat sequential order. So it's unordered data, and the I/O is slow. And then you have the transaction logs, and on a traditional database, and all this technology comes from the sort of 80s and 90s, even up until 10 years ago, we were all running on spinning disks. So you wrote your transactions out to the transaction logs. It was super, super quick because it was sequential writes. And when data came in, you just kept a copy of the unordered data in memory. And periodically, there's a job in the database, certainly on Oracle and Postgres, called checkpoint, and that writes all the dirty pages in memory to disk. And that is really, really important for consistency. And developers are very unaware of it because, one, it's in the background. It's pretty much invisible. I like in the latest version of Postgres, log checkpoint is now on by default. So the Postgres, the devs will at least see it, but it'll be quick because on their laptops they have small data. But on big systems with lots of RAM, a terabyte of RAM, someone mentioned 10 terabytes of RAM for a server. I'm just thinking, like, how long will your checkpoint take? It's like, what's going to happen there if you have buffers that big? So it's, this is for really big systems. It's a crunch. And it's the bigger you get, the more of an issue checkpoint can become. And we have some really busy systems at Adyen. So checkpoint is something which Adyen does a lot of work tuning. And it's something which is implicated in failovers and switches. So those are the concepts. Let's start. Should we start playing? I think we're ready.
Yeah, I think so. I almost knocked out the sponsor raffle thingy, so then we would already have a winner. So I will be careful, I'm sorry. Today, we have a very simple application. Financial transactions are just complicated. So today we have an application and we are processing cards. We love you all, so we start with the hearts. So yeah, I thought this might be a challenge with the mic and the cards. All right, so I'm an application and Dave will be the database.
Okay. See if I can do it this way. Cool.
All right, Dave, I have a two of hearts. Just pretend to be a database. What would you do with this lovely heart?
So this is how the game works. So you have the two of hearts, which is one copy of the data. One copy of the data, the big card. And this box is the heap. So this is where all the data is sort of unordered on disk, and it's slow access. And there also, if I'm holding a card up, that means it's in memory. So it's in buffer, but not in the heap yet. So it's quite complicated. But the first thing I do is I take the card, and I take the copy of the card. and I play it to sequentially into the wall very quickly. The transaction is now safe. I can process more data. Thank you. So.
Right. Let's practice some more with better sound this time, maybe.
Okay.
I've got 3 of hearts.
Okay, so I'll go through that all again, and hopefully people online can hear as well. So there's 2 copies at the moment. So there's 1 copy of the 3 of hearts, which I write directly to the wall. Super fast, direct I/O. It's sequential I/O. It's really, really quick. And the copy which will go to the heap, I'm just putting in memory at the moment. So those are the stuff in memory I'm holding in my hand. So shall we do a couple more?
Yeah, I thought I will increase the pressure.
Okay.
2 cards, 1 transaction.
Yep.
How would you handle multiple statements,
I
1
can do
commit?
2 cards in 1 transaction. So I put both the I put both the 4 of hearts and the 5 of hearts in the wall log. And it's all done very quickly, of course.
Has it been committed now?
So, yes, right. So now, but I've got all this in memory, and the stuff which I'm holding in my memory is starting to get a little bit heavy.
You want to clear your memory?
I do. I want to make sure that all this data which is in memory is nicely, securely on disk.
Okay. So how would you checkpoint this?
Well, this is an old-fashioned database on spinning disks, so I write it really slowly to 1 disk, and then I go to another disk sector, and then I do another circuitous route around the room, and I write to the other one, and then I write to another page. So those were slow circuit, long-winded.
But now you have nothing in memory and nothing to do. I can handle this. I'm an application. I have more data for you. I think
Okay.
Boris...
Boris, I need you back.
Can you please stay?
Yeah. Okay. So now we've got the 6, 7, and 8. Right. Okay, so let's process those. So 6, 7, and 8 are now in the wall, so that data is safe.
I've got more.
Okay. 9 and 10.
Just be quick with them. Because I like this part. Because I like when my databases are slightly busy.
Okay.
And you know what happens, right? You have a database, it's a single database, and then some unexpected event happens, so you lose your database. And now it's like, Dave, I've got cards.
Oh, I lost all my cards. So, yeah.
Ah, damn it. Dave, I want to do business.
Okay.
We're down here.
Okay.
Don't run, Boris.
Now I can go to my wall log, and there are also, I didn't mention at the beginning, there are control files which were like pointers, so you know. And I go to the wall log, and I go to the control file, and I say the last checkpoint operation was was the 5 of hearts. So that means I've got to get the 6, 7, 8, and 9 out of the wall, and then from the wall log, I now have, from rereading the wall and reprocessing the wall, I have them back in memory. And then I probably ought to checkpoint them and get them finally to disk. But I think I'm back and ready.
You think you are back?
Yes, I am back. I have the data. Your data is back. I know what's going on. I haven't lost anything.
Well, you didn't lose anything, so the recovery point objective was kind of perfect. But I don't want to be impolite, but it took like forever.
Do you know, I've heard that a lot of these big companies like Google and Facebook, they like using replicas. Shall we try a replica? If Google does it, it must be right.
Well, why would we do this? Like, what do we need? Okay, so I can be a replica. I'm not used to listening to what Dave says, but I will do it today. But we have another problem, because I can stand here, I can listen to Dave, but who can be the application? I have more data to process. I've got a stack of spades. Who can help us out and hand us the spades? Thank you.
Thank you.
Right, please welcome Allard. I'm in one data center, and Dave is in the other. Maybe it's for the application easiest to be close to the primary. Yes. We can remember it, because Look, I've got a red hat. You can be the primary.
Yep.
I will be the blue hat, so you know who's who.
So red hat for primary.
Yeah, I'm ready to listen to you.
Okay, I'm in charge. So
Can you
the
be
application,
next to Dave?
You can only talk. You should really probably best we go that side. The logistics get a little complicated. But
Oh yeah, and now Boris, you need to extend your arm.
thanks, Boris. So the idea is you talk to me, I talk to the replica. You can't talk directly. So we are now playing spades. So this is. Oh yes. So we're.
Oh yeah, I will update the slides.
Yeah, so we're on the next slide. So we're now, this part of the presentation is all asynchronous replication. So we have a primary with the red hat, a
replica
with the blue hat, and we have, sorry, it was Ellert who is playing the application. Cool. And the application has given me the first bit of data to process, which is the 2 of spades. So now I put the 2 of spades in memory, like before. I write it to my wall file, and I can get another transaction, because your data is now committed, so it's safe. But in the background, I'm also, and it's difficult to do because I'm not multi-processor computer, but I'm giving this to Dirk. So Dirk also has a copy, or the replica also has a copy. So, and if you give me the 3, okay, so I save the 3 in here, and I pass the threes on both sides, 2 copies for Dirk, because he's got 1 for the heap and 1 for the wall. So I maybe do the 4 and the 5 together. Okay, so the 4 or the 5, they're in my hand, so they're nicely in memory. They're on disk in the wall file, so fast writes, and I give them to Dirk. They got mixed up in the internet and they come out in the wrong order. But,
I can manage.
Cool.
I have all the time in the world.
So, okay, so what's the next card? Okay, so everyone can see the next card's the Joker. So let me play the Joker to Dirk. And
I lost that transaction.
yeah. It was a select query, the transaction, so no data was lost. So this select query is, how many spades do you have at the moment? So on the primary, we have the 2, the 3, the 4, and the 5. So I respond with those 4 cards. But what happens if we run that query on the replica? Sorry.
Well, I received up to the 5 of spades. I've written them to my wall file. But let me see what I actually have. You can only read the 2 and the 3 at me. I pretend to be slightly busy. I was not. But still, everything what I receive and I write it to the wall file also has to be processed so you can actually read it. So even though I received 4 cards, I've been only to apply 2 of these cards to the heap. So if you would ask me at this moment, what cards do you have and what cards can I read? It's only the 2 and 3 of spades. So I'm slightly lagging. Letitia already did a good job explaining the difference between application lag and reply lag. No, reply lag. Yeah. So there's a difference between not having received a card and not having applied a card. There are 2 different kind of lags, but for a developer reading from the replica, they both matter.
Okay, so we're going to play some more. Let's play some more transactions. So if we play the 6 and the 7.
Oh, I'm slightly thirsty, Dave. I will take a sip of water, but you can keep doing business.
Okay, we've lost Dirk. He's not paying attention, so we'll just put Dirk on hold for the moment. But we carry on processing the 6 and the 7. Okay. And the application's getting impatient, so we're going to play one more card. So we'll play the 8. Okay, and we're just giving up on Dirk because...
Oh, I'm here, just waiting.
You're just waiting?
Yeah, did you miss me?
I thought you'd gone for a drink.
Yeah, I'm not drinking like for the rest of the day.
Okay.
Just a little bit.
But the problem is Dirk is now lagging.
No, I'm up to date.
Well, Have you got the 7?
No, I didn't have the 7, but I was not aware of this 7. It was just lagging a little bit, but I didn't know about it.
Okay.
Only you knew, I guess.
Right, but in terms of the risks of asynchronous replication, it is possible, in fact, it's quite likely to get lag in the system for various reasons.
I think I hear our DBA talking.
Ooh.
I actually like what she's saying.
Okay.
She does a proposal that I should become the primary and you can listen to me. You do what I say.
Actually, I like this. There's less cards as the replica to hold. So
That makes sense.
okay, so we're switching.
How can we prepare? Because we know it's coming, it's a week in advance. Can we do anything to make this process as smooth as we can?
Checkpoint.
Okay. I go first, you go first?
I'm going to go first because I have a lot of checkpointing to do. So, okay. So I now write all my data to the heap and sort of circuitous path. Really wanted a big box so you could see that I could place them over here and over here. But in the end, I have on my old spinning disks, I've written all my cards to different bits of disk on different drives. So very much random I/O.
All right, I have not much to do, I think. I only have 2 cards to go. I was already pretty much up to date, so I will do this one and this one. I'm good.
Excellent.
Are we ready?
I think we are.
All right, let's go.
Okay. So.
All right, let's switch. This is so much better. I like to be in charge. So, Dave, you've been the primary for quite a while.
Yep.
You were standing here with all these cards. I can imagine maybe you're a bit tired, or you need some maintenance, maybe operating system upgrade.
Well, you know, those people from security have been around, and they keep saying, I have to run that patch. So
Right.
I'm going to take a break to run that essential patch and make the security team happy.
Right, if you do the job, we are an asynchronous replication system anyway, so
yeah.
I will do business with our application alert. I'm good.
You told me.
Yeah.
Okay.
I can do this. Ooh, even for me it's complicated. All right, let's save some cards for Dave, card for the wall. Yeah, good. More cards. Save something for Dave, something for me, something for me, something for Dave. Dave, are you there yet?
Yes, I'm just coming back slowly. I need one more reboot for the security patch, but I'll be with you in 5 minutes.
Ready in 5 minutes. I guess you don't have that much memory then. Right, so this is a nice situation, right? Finally, we managed to do the painful security update on the operating system. Application didn't notice. We were able to do some business. So I think this is a good situation, but there's only one downside. I have these spades up to the queen. Did I commit this? You're pretty sure I have it, right?
The application is sure that it is safe.
Application
committed.
just telling me the application is very well aware that all this information is safe. But Dave doesn't know, and Dave is my backup. He's my replica. So if something now happens to me, this data gets lost. Allard thinks this is actually committed, and Dave knows nothing about it. So if I just leave with these cards, pretend to be in my pocket, this data gets lost, and nobody knows. It's kind of an ugly situation.
Well, there is another option. And it's going to fix all our problems, I'm being told.
Right, I like it. I like perfect solutions.
So the perfect solution is synchronous replication. Let's play synchronous replication.
Why? Do we have any valuable things to process?
I mean, think we've got...
just losing some spades, it's not like a big deal, right?
I've heard we've got some diamonds coming our way.
Ooh,
and we don't want to lose the company diamonds, so...
Okay. Is there any price involved? Is it like, do we have to pay more, or...?
Well, the truth is we can't afford to lose any diamonds.
Okay, so just be careful and then we're good. And then everybody happy.
Well, let's play and see.
All right, let's have some diamonds. Let's process some diamonds.
Okay.
These are hearts. We love the hearts, but they're not that precious. Cool. I've got diamonds. All right, we have some diamonds. Let's process diamonds because nobody wants to lose diamonds. Now, can I just start with the 2? Let's see how it goes. Yeah, just the 2. Just start easy. Dave,
Okay.
I have diamonds. Don't lose
Excellent.
them.
Okay, so the diamonds are going in the wall. Dirk, I have... I don't have a commit token.
No, you don't have commit tokens. We don't have enough.
I have a virtual commit token, which I'm passing back to the primary database to confirm that this transaction is securely in the wall log.
Oh, cool.
So,
I can also write it to the wall log, so we're safe, right? This the 2 of diamonds has been committed. It's really safe. Great. Cool. Application is happy. He's smiling at me. Okay. Right, Dave. I've got 3 diamonds.
3 of diamonds. I have the 3 of diamonds. The 3 of diamonds has been recorded in the wall log. I pass back a virtual commit token.
I will also commit the 3 of diamonds. 3 of diamonds have been committed. Oh, this is going so well. We're never losing them.
Yeah, get on with it.
I have the feeling my application...
That is the sound of our devs.
It's taken a
4
long
of
time.
diamonds are in the wall log on the replica, so we.
Multi-threading.
Oop.
Did you commit the 4?
Yes.
Right, let's...
The 5 are on the replica.
Oh, and the 4. I lost track of my administration. Right, they're on the wall. I committed everything. I think we're doing a perfect job here. We are so safe. We will never lose any diamond. There are no downsides, right?
It's taking a long time.
Sorry?
It's taking a while.
It's taking a while. Yeah, but it's secure.
I'm hearing a voice. It's the voice of the DBA manager who's coming in. And hi, Rita, how's it going? There's a problem on the Dutch trains, and we don't know where Dirk has gone. Okay, I will take over from Dirk. So the first thing I have to do, if I'm going to take over from Dirk, is I have to make sure he's properly down. So this is revenge time.
Hey! I was the primary here. What are you doing? You know what? I stopped being the primary. Screw you.
Yes.
And I take the memory with me.
Okay. This is an ungracious failover. So I'm now the DBA in charge, and the first thing I have to do is grab the red hat. Okay, so I'm now putting on the red hat, and because I am now, all the DNS has been, or whatever's been updated, everyone is now talking to me, and I can start processing it again. Turn this hat round. So, 6 of diamonds. Okay, now there's a problem. Indeed, I've lost my replica. So this is awkward. Okay, so at this stage, we get an unusual wait event, and lots of people in the war room. So it's lots of excitement. And eventually, I think, we have this data center. Let's use the backup. So we have a third option. But there is a problem with the third option.
Why? I'm here. I'm not sure that I'm still visible online, but...
Yeah, but the problem is that I've hurt my leg, and now you're a little bit further away, that we're going to need to have a network volunteer.
Well, I'm tall. I have very long arms.
Fantastic. So... you can call me Tux. Tux. Okay, please come on stage, Tux. A big round of applause for Tux, who's going to play the network. So, if you can... okay, so we have a DC, and we have a network volunteer, but the problem is we haven't played the 6 of diamonds. So the first thing is 6 of diamonds. If I give that to the network guy, Tux, if you can take that...
No, it's also inefficient network today.
I think we have a routing problem as well.
Right. Can you give this to Dave so he knows this has been committed?
And can we have a network person in this room? That routing. Okay. We are back in business. So we have the real token now. So I have a commit token. I actually can record that. So that the 6 of diamonds has been processed. So let's do the 7. 7 of diamonds. This is the card for Dirk. And then, okay, the network's running a bit smoother now, at least the routing.
Thank you. Can you give this token to Dave so he knows I actually did commit this?
Okay, excellent. I have the physical commit token because these are big amounts of diamonds now. So let's record that as well. That's been processed. I put the commit token and yes, so, but that was human error. A real database wouldn't do that. Okay, so. Okay, thank you, network.
Right, thank you. Can you please wait?
Okay, so.
I know what's coming.
Now we're freezing time, so we're really down in the millisecond time frames. But this is, you've got to think about these edge cases when you're a DBA. So the next card is actually a query. So if we have the query, and I'm just going to wave, it's a joker at the replica DB. So the question is, how many diamonds do you have? And in my case, the last diamond played was the 6 and 7, and I wrote that to the wall log. But the 8 of diamonds, I have it in memory, but it's in a special status of uncommitted. And I'm not going to return uncommitted data. So I will return the 2 to the 7. Dirk, what do you have in memory?
Oh, actually, I received everything, and the commit token for the 8 of diamonds is on the way to you. So I committed 8 of diamonds already. So if you would ask me, what diamonds do I have? I can show all 8 of them, which is kind of a weird situation, because if you would ask Dave, even though he's the primary, he's slightly lagging. I know this is kind of an extreme situation, but I always think this is kind of funny, because when we talk about replication, we usually talk about lag. Apply lag, replication lag. But now the network got disturbed. I have committed, and I'm ahead of Dave, even though I'm wearing the blue hat. It's pretty cool.
It takes some thinking about it. The replica is ahead of the primary, because most of the time the replica is behind the primary. Even though we have sync commit on, there is still the potential for apply lag. So you won't lose the data, but if you query it, most of the time you will miss data or get the right data. But in practice, you can also go in the future. So sync commit has a few edge cases as well. So it does take quite a lot of management, and not everyone at Anadian is a huge fan of sync commit all the time. Although we don't want to lose the diamonds. We are a bank, so we're not allowed to lose the diamonds. So.
Well, do we care about commit tokens? That's a good question.
Well, absolutely, because without the commit token, the 8 of diamonds will never be saved. But honestly, this is the end of the presentation, so...
Right. So all diamonds have been committed.
You'll be pleased to hear the 8 of diamonds is safely in the wall with a token.
Allard, thank you for being our application today. I have some Dutch treat for you, and you were slightly shorter on stage, but it was a lot of hard work and running, so also for you, some sourdough waffles.
Thank you, Vel.
Thank you very much.
Well, thank you very much. Okay. Thank you.
So, replication. When you see it happening so in front of you, I think it makes a lot of sense that there's actually transport involved, there are delays, and there are different setups. And I would argue all setup is equally good as the other ones. There are times you just need something else. We can always have a synchronous commit situation, but it's hard. All this transport creates lag. And if you have a single replica and synchronous replication, if you lose the single replica, you're already out of business. And also probably there's more network involved. So when you have synchronous replication and only 2 clusters, the risk is more than twice as big as having a single cluster for having an outage. So if you want to have synchronous replication in kind of a safe way, I think you need at least 3 databases.
And that's what I assume most people do. Yeah.
Yeah, but it means you have 3 times the hardware, 6 times all of the data. So it's not like you don't have to pay anything for this complicated system. So if you don't need it, just don't do it.
Absolutely. And we have a lot of data to look after. So it's not cheap once you get to the scales. We are having so many copies, but yeah. We don't want to lose the diamonds either, so
No.
sometimes we do it.
But sometimes a single database is a perfect solution for the problem you have. Maybe this is some reporting database and some reporting folks are working with this database, and if it's down, maybe a few people are having coffee for a few hours, but it's not like a disaster. We will refill this database, whatever the data came from original source, but we can rebuild it, so there's no need for any complications here. So in these cases, a single database is a perfect solution for the problem.
Absolutely. So, yeah, I mean, we do use all 3 data types, all 3 types of replication, standalone, asynchronous, and synchronous replication. There are more options and things to tune and more edge cases, but it already got quite complicated in just the 35 minutes, and this is above the level at which most devs get to. So, yeah. Hopefully, if we had devs in the audience, I was meant to ask, how many devs do we have in the audience?
Quite some.
Devs, developers, but QA or product, but non-DBA specialists, because mostly it's a mixture of DBA and then a whole bunch of other people. So, so that's very much the target audience. I mean, for DBAs, it's, hopefully you know all this already.
Still, when I look at these 3 systems, I would say asynchronous replication is maybe the hardest one to really understand and manage well. I mean, I can easily understand the single database because it's down, and you just wait. I also understand the synchronous system because your data is really safe, but you pay a relatively high price for it. But the system in the middle, I think it's the most widely used. But for me, maybe it's different for some of you, but I always think this is the most difficult one to explain and actually understand.
I'm still taken away with the fact that sync replication, you can be ahead and behind. And you don't know. That's the one which just like makes my head hurt, but for reporting and potentially for failover.
Okay, so we're pretty good. Replication, usually we don't lose data except for the asynchronous replication. When you have a single database and you have to wait for it to come back, the recovery time objective can be high, but you don't lose data. For the asynchronous replication, the recovery point objective might be significant, nobody knows, but at least it's quick back online. And for synchronous replication, you pay the price in delays all the time, but at least the RPO and RTO are really low.
Absolutely. So, any Q&A?
Should we talk about network?
Oh, well, I mean, the network is the bane of the, of the distributed systems. So Letitia mentioned CAP theorem. So, are you going to go for consistency or are you going to go for availability?
Yeah.
If our network problem.
Okay. And today we only have been talking about high available databases or database clusters. We didn't talk about backup. I would not recommend you just having these systems and no backup. That we didn't mention it in this context doesn't mean you don't need it. Just to be sure. All right.
Cool. Yes, I think that was the very final point on the slide is you always need a backup. This is high availability. So some people get confused because the replica is a backup for availability, but it's not like a traditional database backup. If you corrupt your data, there's an Adyen bug or there's a PostgreSQL bug. Both happen very, very rarely, but they're things we have to protect against. We could lose data.
I think we have seen both.
We have definitely seen both. I mean, these are very big, and Adyen hits all the corner cases, the scale.
But let's keep it easy. Let's stick to the systems. And are there any questions? I will be giving my mic to Teresa.
Thank you. Before we start the questions, maybe just let me offer electrical elephant to Derek, and another for Dave, and an additional one for Thomas for all the help with the song. So say thank to him, please.
Will do. Thank you very much.
So, questions. Do I see any? Okay. Dave, can I have your mic, please? Thanks. Thank you.
I'm looking forward for the in-person quorum-based replication and with the split brain for next time.
Yeah, we worked hard to keep this story relatively easy. I know there are very ugly edge cases and there's enough material to talk for another hour. Maybe we'll do it one time. I like the invitation, but for today, we just try to keep it easy.
Okay, last question, please.
I volunteer next time as failover manager.
Okay, I think we can wrap up and go for lunch, if I'm not mistaken. No? Oh, oops, sorry. I'm a bit too hungry. Yeah, so let's give 2 minutes for Derek and Dave to disassemble everything.
Yep. Yeah, I will do it.
Come.
Just to prepare.
Ah, okay.
Then we both have to come, yeah?
Okay, I think we are ready to start. Okay, nice. So let's move on. So next speaker is, I'll try to say it properly, Peter Eisentraut. Okay. And he's talking about column encryption. So welcome.
Yes, thank you. So sorry, no lunch yet, but I'll try to increase the technical complexity here over the previous talk. Is this? It was blinking a moment, or maybe that was just me. So, yeah. So I'm a Postgres developer. I work at EDB on Postgres development, and this talk is sort of a summary and assessment of something I've been working on and researching the last 2, 3, 4 years. And this is something I've so run into a lot in my work, and so I want to explore this topic. And this is probably going to be a lot of technical information, and each slide could be expanded in a whole nother talk. So don't feel bad if you're not following every single item, and I'm glad to sort of have separate follow-ups for some of these things. So this is more sort of a summary of a lot of possible issues. So it might be a little bit quick, but we can go into lunch, right? All right, so let's sort of motivate this in a really general way. Why do we want to encrypt anything in a database? The first point is kind of obvious. That's what everybody thinks, right? That you have data. Data is important. You maybe want to encrypt it to hide it from people who shouldn't see it, right? That's well understood. The other points are maybe less well known, but they're interesting to think about as you explore possible solutions in this area, right? So the second point is sort of what often goes along with encryption. Encryption hides the data from people who shouldn't see it, but possibly you also want to prevent someone from altering the data without authorization, right? Because even if you encrypt something, someone could go in and change the bits and bytes and it's something different, your data is falsified. So you might want to protect against that, right? So we have this in the area of SSL, we sign certificates, right? So we know they're correct. And so this often goes together, right? So that's something to think about. It's not necessarily, I put the question mark there because not necessarily everyone needs that, but it's something to think about you might want. The term crypto shredding is something that comes up sometimes that is actually quite an interesting application for encryption. What this means is that you might have a requirement at some point to delete some data, right? Oftentimes these are regular requirements or sort of policies that you set for yourself after, I don't know, 6 months or 7 years, we have to delete data. And it is, if you think about it, often actually quite hard to really delete data. Right? Even if you do it in the database, as we kind of just learned here throughout the morning, that it's not actually deleted, it's marked invisible, basically, right? Until maybe vacuum comes along, but vacuum doesn't actually really delete it, it just sort of marks it for reuse, and then on the file system, it may be still there, and so it's not really gone, and it's sometimes hard to satisfy yourself, have I actually really deleted that data to satisfy my obligations? And the idea with crypto shredding is if you encrypt the data and you throw the key away, that should be good enough. And so that would arguably satisfy those requirements, right? So if you imagine maybe you sort of partition your data somehow, and then after a while when you need to remove the partition, you just delete the partition as you would normally do, and then also throw away the key that goes with it, and then it's gone. So that's actually a kind of really useful application of encryption. And then you have regulations, policies, laws that apply to what you need to do. Sometimes you might think, like, this is stupid, why do we need to encrypt this? Some regulation says that. It could be laws of, public laws or regulations, or something your company has just defined. The security department in your company says, well, we need to encrypt this, and then you just need to do it. So oftentimes when I engage with customers and explore what you actually want, and then we talk about it in the team maybe, so what are they actually trying to defend against, right? What are they protecting against? And the answer is often they're trying to protect against their internal auditors, right? That's the adversary, right? So it doesn't really matter why, it's just they say, so we have to do it, so we just have to do it. And it's not really our job to become cryptographers and figure out why, it's just we have to do that, okay? And that's actually quite important in practice, And then the final point is good to keep in mind, defense in depth means that maybe one thing doesn't protect sort of absolutely, nothing protects absolutely, right? Doesn't protect absolutely against anything, but if you build a stack of things, like you have firewalls, passwords, just general policies, password rotation, whatever, right? And encryption and privileges and access control and auditing and logging. If you build all of this, then if anything goes wrong that you didn't foresee, the more layers of defense you have, arguably the better, right? So keep those other four in mind just today, but also in general when you think about encryption. It's not just about hiding data, but it's also possibly about some of these other things. Okay? So there's a bunch of different scenarios in which you might run into encryption in the context of a database. And so the first one is, I guess, well solved, right? Transport encryption, use SSL. That's, not without challenge to configure correctly sometimes, but it's a pretty well-established thing that you should use. So the other ones I want to talk about is encryption at rest is either encrypting the disk, or you have what some people call TDE, transparent data encryption, so the database manage the encryption, which is not built into Postgres, that facility, but lots of vendors, including my own employer, has proprietary solutions for that. You can use those as well. Now, and that's fine for many people, but when I talk to customers and sort of explain how this works and what are the options and so on, oftentimes, sort of, I would say almost half the time, this is not actually what people really were hoping for. But because the encryption at rest is, as the name it's just encrypted on disk, but not in sort of the live system, right? So you protect against, sort of losing your disk, which, is okay, but what people are really hoping for is some kind of scenario where for certain data, the database server doesn't even see that in a plain text way, right? So it is encrypted before it even gets to the server, and then the server can't even see it, and so it's even further protected that way. And that's kind of what I wanted to explore, how you could do that. And this has sort of different terminology. I mean, and obviously in my title, I call it column encryption. In other database systems that don't have columns, that have fields, that they call field encryption. So it's sort of per datum, basically, right? And the important thing when you look through all of that is also that different vendors sort of slice up their terminology differently. Right? In the Postgres sort of ecosystem, I guess we have sort of settled that TDE is encryption at rest, and then I guess column encryption is column encryption, for example. But for example, if you look at Microsoft SQL servers, encryption facilities, they, I believe, call TDE is basically all the encryption facilities that they offer, and then you have full disk encryption, column encryption under TDE, right? And they have some marketing brand names sometimes wrapped around them. So it's sometimes hard to navigate what the high-level terms mean. So kind of just dig into that, right? If you're exploring different solutions. All right. So here's I mentioned regulations. Here are some of the ones you might run into, and there's many more, but these are the good ones to sort of motivate and explore different challenges. And I guess they're also sort of easiest to understand. So, for example, PCI DSS is what you need to follow when you deal with credit cards. And that's actually also kind of a good one that's easy to read. So that's often used as a motivator in context of encryption. Everybody here knows GDPR, right? So that's different, right? PCI is very concrete. You have to do this, you have to do this, you have passwords, you have to rotate them every so often. So it's very concrete. You can follow it relatively easily. GDPR, as many people know, is very general. It's like you have to use state of the art. You have to follow, technical and organizational measures and stuff like that. So it's very abstract. You have to kind of interpret it into that. FIPS is a standard that applies basically only if you interact with the United States government, but many others sort of voluntarily adopt that, so you will run into that a lot, especially if you deal maybe with customers in North America that are highly regulated. They say, well, we need FIPS. That basically just means you're limited to certain encryption methods that you can use, and they have to be specially certified and so on. And then HIPAA is another one you run into in the US if you deal with medical data, and there's many others. But the thing is, depending on what you do, what your business does, different ones might apply to you, right? If you're in Europe and deal with credit cards, then you need to PCI GDPR. If you're dealing with medical data in the US, you have probably FIPS, HIPAA, and there could be different combinations. So not all of this applies to everyone in the same way, and as we'll see later, this is kind of a challenge as you sort of pick what you need to do. So this is kind of ideally where we want to, sort of the ideal scenario, how we could do this, right? So we have some, on the client, we want to insert some data, but we don't want the server to see it, so some part in here has to encrypt it. I'm using libpq, but some code here has to encrypt it, and then we want the server to not see what the actual value was. So this is kind of the ideal scenario where we want to get to. And the question is, how could we do this? So I have to put some code here, right? So how could we do this? And so then you start exploring of like what are possible options to do this. One thing you have to keep in mind if you do this, you have to also make sure your queries are clean in the sense that you don't accidentally leak these sort of values to be encrypted. So you have basically you have to use parameters because whatever component does the encryption needs to know what's your query string, what's your data. If you just write it like all in one string, it doesn't know that because the parsing happens on the server, right? So your application code doesn't know what the values is really without doing its own parsing. That's why obviously this is the same problem with SQL injection. So sort of clean code already does that, right? That you have to use parameters to plug in your values into your query strings. You have to use that. So that's what you have to use when you insert data. If you want to look up things, unencrypted things, that's fine. You can use it either way. How would it work if you want to look up encrypted fields? It's kind of hard, and it depends on sort of what solution you have available. Again, if you write something like this, the secret value gets leaked to the server, so that's bad. This might work if you just plug the pre-encrypted value in here to look it up. That might work, but it might not. We'll talk about that later. Something like that, and I mean, just in general, any kind of operations on the encrypted field obviously won't work in general, right? So this is always the trade-off that you have. If you want to encrypt your data before it gets to the server, you can't do any operations on it, really, right? That's the trade-off you have to use, and that's something you have to manage and think about how far you want to take that. We'll see. We'll talk about that again, have some possible trade-offs there. Why do this, right? I guess what some people do when they have like this data has to be more encrypted than this other general data, right? So we have the credit card numbers, PCI DSS says we have to encrypt them. There's all this other data. One thing you could do is just put it in a separate database that's more protected in some way that satisfies your auditors. But I guess the idea is if you combine this all into one database, you have the benefits of your normal integrity in your database that you have. You have referential integrity, you have consistent backups, consistent replication that we just talked about, and so on. If you have it all in one, otherwise separate database, hard to keep in sync, right? So that's some options you could do. Another thing is you could arrange it depending on how you set up the keys that only certain clients can read the encrypted fields because only they have the key. So that's actually could be quite useful, right? And another thing someone else told me as a potential use case for this, I'm a little bit skeptical about that, but the third point is you could take your database and kind of copy it to a staging system maybe, and the sensitive fields are encrypted, so the staging system doesn't have access to that, so maybe that's a little bit safer. But you have to think about if that's safe in your environment. So those are some advantages of that. So I think client-side encryption is actually sort of useful security, unlike TDE is a little bit more compliance theater disk encryption, right? If you do it on the client, I think that can actually give you real security, but it's actually quite hard to do. And so that's what I want to explore. The easiest solution that people will make you believe, I guess, is let's just put a proxy in the middle here. And there's commercial solutions out there for this right now that if you look for, Google for certain combinations, you will find these. There's various companies that sell this, that work with Postgres and maybe other database systems. And it kind of makes sense as an architecture, right? You have your unchanged application over here, you have your database over here, and then something in the middle takes care of things. That's what we all kind of want, right? The problem I think as an architecture, this could make sense. The problem I have with the actual solutions that are out there is that they don't really tell you what the question marks are. And that's for encryption, this is always a problem if there's no transparency, at least that's my opinion, right? So they tell you that it's taken care of. Then you ask them, so what do you actually do in there? It's like, well, you know, we have all these certifications and we are FIPS compliant and this and that. It's like, but what is the actual encryption methods that you use? Well, that's proprietary. So I don't know, make your own decisions about that. But that's kind of where it is, right? Yeah, so I guess it is easy to use, but the details are unclear, and you obviously have to get some third-party software that may or may not last as long as your database, right? I guess apart from a proxy, the easiest solution is, which is I guess what many people do now, is that you implement this yourself in the client code. And here's sort of abstract example, which is Python, but you know, you can just import, and this is intentionally vague here, right? You import from some library an encryption function. You get a key from somewhere, and then you write your normal code, but before you insert, you encrypt it. Right? So I guess that would work. I saw somewhere when I was preparing this, Jan is the most common male name in the Netherlands. Is that correct? The second most common one was Peter, so I didn't use that in the example. So that's why all of these ones say on. But I guess this is sort of formally compliant, right? This does the job. But the disadvantage, obviously, you have to do all of this yourself. You have to re-implement this every time you use a different programming language, or every application has to make sure it correctly does this every time I'm dealing with this encrypted column. I have to make sure I really do this correctly. So it's probably going to be very, very difficult to do at scale in a large organization to keep this all in sync. So I guess this is what people do. You can do it now, and if you need to do it. But I guess this is sort of the starting point, and we're kind of looking for a better solution, right? The other thing you will find, if you look for this, and there's always PG crypto. And PG crypto is almost always the wrong solution for anything. Unfortunately, it is always there. It's like, yeah, I should encrypt something. Why don't I use PG crypto? Right? It also has an encrypt function. It's literally called encrypt in this case. And then you can encrypt things. So you give the value, you use your parameter nicely, right? And then, well, but you got to put the key here somewhere. That seems bad, right? To put the key here in plain text, then it's just in your logs. It doesn't. And then you put an encryption method in here. So that's obviously, people do this, but that's obviously bad. You could, instead of just putting the key here in plain text, you could also put it as a parameter maybe, or you can use some function like this to get it from a file, or or any other function you write yourself to get the key from somewhere, but it doesn't feel satisfactory, I think. But you see this a lot, and it's, I'm just basically warning you against it, right? Because it doesn't seem sound. Right? It's also not client-side encryption, which is what people never really tell you. It just does the encryption in the server, so it is kind of a mini TDE. I guess you could use that if you need a TDE solution, but you can't get your hand on one for some reason. You can sort of build your own mini TDE here. You can wrap this all up in views and updatable views, so you can make this probably quite transparent, but it doesn't feel satisfactory, right? The other problem, independent of all of the sort of the architecture considerations, that PG crypto itself is really antiquated in terms of what cryptography it supports right now. So some of you who might know what all these abbreviations mean here, so AES CBC is really outdated, and it shouldn't really be used anymore in this way. So lots of question marks here. This is actually sort of maybe a nicer solution if you can do it. Many frameworks or ARMS kind of things have sort of usually kind of a plugin or something where you can say, just encrypt this field. And this is an example from Django for the Django cryptography extension. So that seems pretty nice, right? So you say, this field should be encrypted, done. And underneath it does all of that, like I showed the Python code earlier. And it calls it all correctly, sets it up correctly. So this is nice if you can use it, right? If you just have your little Django application, then you just use that. That should be okay. But it's obviously not usable if you need to support like a wide range of stacks and combinations in an enterprise. Then this is just sort of an isolated solution that for one application. The other thing you need to be careful is there's a lot of, like for example for Django, there's a lot of different plugins, and they're not all the same in terms of what they do. Right? So this one I found seems to do the right thing because it does client-side encryption like the Python code I showed earlier, but there's also some Django column encryption plugin that just wraps around PG crypto, and then it has all the drawbacks of what I just explained about PG crypto. So you really have to make sure you pick the right one. And I picked the one I showed here. I looked at it for a little while and it seems sound, but there's a lot, and you just really have to evaluate what you pick, not just pick the first one. Right? Because basically everyone can write a Django plugin or a Hibernate plugin or something like that and upload it to the internet, right? It doesn't mean it's good. But if you can use it, if you find the right one, I think this is probably a sound solution. So I think these are sort of basic approaches you can take. We'll get to a couple more complicated ones in a bit. At this point, I want to work through some of the encryption details. And when you're faced with that, I guess if you use this one, you don't have to worry about it because you just say encrypt. But if you hear, then it's like, okay, there's ASCBC. Which one is that good? I don't know which one. There's all these different acronyms you find, different ciphers and key lengths and modes and initialization vectors, nonces and keys, and where do I get the key from? And so if you want to build this yourself, you have to you should worry about all of that. Many people don't. Right. So here's a couple things to think about. This will maybe come up. You can think the terms. Sometimes the terms are slightly different, but I think these are good general terms, right? So we looked earlier at the example, if I have an encrypted column, let's say I encrypted the credit card number as I'm required by PCI DSS. Now I want to look it up again. That could work because you just encrypt the credit card number in the client in the same way, and then you do a search for the encrypted blob. That could work. So you might think, on a basic level, yeah, if I encrypt the same string or encrypt the same value multiple times, it should always give you the same result, right? So if I encrypt foo, it should give you this. Encrypt foo again should give you this. It kind of makes sense, right? It's just a transformation. And it does do that, but that's generally not what you want. And that's generally not what most systems do. What most systems do or prefer to do or recommend you to do is do randomized encryption. Where are we here? That every time you encrypt something, there's some randomness mixed in, you get a different result. And that's probably what you want in this context, because if you think about it, let's maybe think about an example like a medical database, right? You have like a name, patient name, and then some diagnosis text maybe that you want to encrypt. If the same string always comes to the same value, you don't see what the value is, but you can see the distribution of the values, right? And so if the diagnosis in some, whatever context, you can infer what the context is. Maybe it's all, I don't want to trigger anyone here. Maybe they have a cough, right? That's the diagnosis here, right? So if statistically, statistically 50% of the people who go to doctors just have a cough, then you can just see, okay, well, 50% of the encrypted values are that's probably then that one. So that's really actually bad because it leaks data. So what you really want is every time you encrypt something, you want to have a different result. And then those sort of statistical distributions are hidden. And that's what you should do by default, but then you can't do any queries by that because every value is different, right? So this is a trade-off you can make. I gave the example with sort of a medical database but let's maybe look again at the scenario with credit card numbers. Most of the time, the credit card number is only used once ideally, so in that case, you might decide that I'm taking I'm making this conscious trade-off that I'm using deterministic encryption, even though it's technically less secure, but I want to have this additional functionality. So you have to make these trade-offs depending on your application requirements. So there's not like one solution that just would fit everyone. And then the other thing you often see when you look for these kind of solutions is something called homomorphic encryption. So homos is same, morph is shape, I guess, right? So that means encryption of the same shape. And the idea there is that, in general, that the result of the encryption process behaves the same as what you encrypted. That's kind of the general idea, and this could have different shapes and behaviors. So here, for example, this is one example, right? You encrypt a string, you get a string. You encrypt a number, you get a number, for example, right? So it has sort of the same shape at the end. Or also, more interestingly, the same operations can be done, right? So if you concatenate two strings, it's the same as the concatenation of the encryption, or sometimes it allows substrings and things like that. So there's a whole variety of different homomorphic encryption methods that have certain properties. Sometimes you can maybe do addition of numbers or something like that, right? You will see this a lot because it is nice. It solves this issue like, well, I've encrypted the values, but I can't do any computation with them in the database. Well, and then you, like, how can I solve this problem? Like, use homomorphic encryption, that's what it is for. But the problem, at least according to my research, this is all very dubious because these homomorphic encryption methods all found to be insecure in some way, or not certified, not widely scrutinized, and every couple of months someone comes up with a new one, and they have a mathematical proof that it does this or that, but it's again a warning against that. For example, one sort of subset of homomorphic encryption is also order-preserving encryption, so that the encrypted strings order in the same way, so you can maybe do sort of statistical analysis on the encrypted values if you want to. Well, that is bad, I think, because let's think of an example. You have a plain text name and maybe an encrypted salary, for example, right? You don't want to show the salary, so you encrypt it. But then if the encryption is order-preserving, then you still show data. If you see the whole table, you see, well, I don't know what the actual salary is, but I know I'm like up here or down there, right? So I think that's just bad. So I would really stay away from that unless you really know what you're doing. There are solutions. I read about something sort of in the lead up to this, which I think is like a valuable application for this, for example, where if you have a smartphone, a lot of them can do call screening now, sort of if there's like a number known as spam or sort of a annoying caller that you want to block. And so the phone would look up the number in some service, and the service say block this, right? But this should be encrypted because otherwise whatever that service is knows all the people who have called you. So ideally they don't want to know that. And they can also do sort of prefix lookups and stuff like that. So if you really design this as a closed system, it's like I really know I'm only looking up phone numbers, I'm only doing this, then you can pick a homomorphic encryption method if you have people in your team who know what they're doing. But as a general, just like fix everything solution, I would really warn against that. This is also maybe something that's not considered. If you have a short string encrypted, you get a short encrypted output, right? If you have a longer string, you have a longer output. That could leak data, right? If you have some kind of idea of what's in your database. So maybe the most common value is none, and then you get something short, and if the text is longer, then you don't know what the text is, but there's like, well, there's a lot of information in here, right? This person maybe has lots of things being said about them, right? So that could leak some information. So this is hard to avoid in general, but some encryption methods do is they pad things at least to some sort of multiple of 16 usually, and something like that can hide that. But it is very difficult to do this in general. That seems to be, in my research, essentially an unsolved problem. Now you could say all my strings are at most 1,000 characters, you pad to 1,000 characters, that's okay. But if you don't know, then it's a waste space and stuff like that, right? Or you could say, like, I add a random amount of padding. maybe that's an interesting idea, but it turns out that's actually also not good. So there's all mathematical proofs about that and stuff like that, that no padding method will actually work. So that's unfortunate. So yeah, so keep that in mind also, maybe. I think this sort of padding to 16 bytes is probably okay as a start, but you have to kind of be careful about that. And so this is the thing I'm struggling with as the implementer here, right? These are all like, okay, what mode can I use? And then ideally you want to have yes in all of these fields here, and as you can see, there's no one that is like just a yes everywhere, right? And so depending on what you need, like ideally you want your encryption mode to be some kind of standard, right? Maybe RFC, something or other, that'd be good. But a lot of these commonly used ones are not, right? I mean, somebody published it somewhere, but there's no what you would call a standard for it, right? Well, not all of them support padding. There's other issues, right? Some of you talked about integrity at the beginning. Not all of them do that. If you have a FIPS requirement, for example, then not all of them are in the FIPS standard at this time, so you can't use them. Ideally, also, if you want to implement this in some system, it might be nice if that mode was supported in a library like OpenSSL or JDK, so you can see, well, not all of them are here. And so that's, up. It's too much information here, right? So yeah, I mean, this is basically the thing where I'm stuck with at this point. You could say like, well, this one is actually, if you dig into the detail, this one is actually kind of the nicest one, but it's not in FIPS. So that's, 50% of our customers would just not want that. And it's only implemented in OpenSSL 3.2, which is very recent, so it's not even like deployed in any system. So it's just practically not useful, right? Or the first one is also kind of okay. The details here we can talk endlessly, but it's not standard. So somebody's, well, this is a method that's not standard. It's very commonly used, but there's no standard document, so it's the auditors will reject it. So it's just bad, right? So you can pick one, but it's only going to be for your scenario. It makes it very hard to just provide a library or something I'll show in a minute, like a general solution that we can just ship to the wider public and say, well, yeah, we picked the right one and it's the one you should use. No, you got to make your own choice or trade-off. It's just hard. And this is also, of course, the best one and that people use. I read an article about this, like somebody said, like, well, this is actually good, but it's not FIPS because there's some computation in there that's not FIPS certified, so I'm changing that to a different one. So it's kind of like that, but I've added my own tweak to it. So you can implement it with FIPS compliant sort of steps in a way, but then it's your own, right? It's not standard, and you're responsible for yourself. So it's just madness. All right, let's look at a couple more solutions that actually is a little more advanced. This is actually sort of you could summarize this as a better PG crypto. This is actually quite nice. PG Sodium, so lib Sodium is a encryption library. PG Sodium is a Postgres extension on top of that. And it's very sophisticated. You can create keys, and it uses this sort of trick, I guess, with the security labels that you say, well, encrypt this column, this one here, right? And it does a lot of things in the background, sets up views, event triggers, and stuff like that, and just encrypts it. So it is actually quite nice. But it uses this algorithm down here, xcharger20 SIV, which is not anything here. It is good, I think, right? But it's if somebody says like, hey, how about FIPS? How about standard? Like, no, it's just that. It's good. But if if your main adversary are your auditors, then that's not a good solution. But I think it is actually quite sound. And it is much more modern than PG Sodium. It actually goes quite deep in terms of what features it provides. So I think it is definitely worth checking out if this is the kind of thing, if you think in PG crypto, think that, I would say, basically. That's the summary. Right? It is still server-side encryption, but it is much more isolated. So I think that's worth checking out. It is a third-party extension, so it might not be available everywhere, but it's actually quite widely deployed nowadays. And this is what I've kind of been working toward, to have this built into Postgres. And there is a patch for that. And this is sort of the way it could look, right? That you set up some keys, and then you tag the column, say I want to encrypt this, and then you set which key you want to use, and then for example this would be the idea that you can then choose here, do I want deterministic encryption or randomized encryption? Or maybe if we feel daring enough in the future, we could say I want to have some kind of homomorphic encryption here that you could use that here as well as an alternative if you want, and then based on what you choose here, certain operations the server would just allow them or not. I think that could work quite well. I mean, the patch does work. But this is basically one of the big problems, like what do we do here? Which one of these do we implement? Do we just give the users like, well, here, pick one out of these 8, good luck, right? That's not really good experience. So this is kind of where this is stuck right now. But at least I would like to get to that because I think, there's a lot of subtleties and problems here, and I think if we could provide a better solution that solves that for a lot of people, I think that would be helpful, but it's not done yet. And there's also a couple of, where are we with the time here? Yeah, there's a couple of maybe also other challenges. If you do encryption in the client, the server can't actually check what you put in that column, right? You say it's an integer column that's encrypted, but the server can't see what you put in there, so it doesn't actually know if it's an integer. It's maybe not always a problem, but that's not a possibility, right? There's no possibility for the server to enforce data types and formats and things like that, or encodings and things like that. So also something to think about. And so one thing we've skipped over here is key management, and that's a whole nother topic. But going back to this sort of simple scenario at the beginning is, somewhere in this pipeline, we want to do the encryption, right? It could be either here in the application code or in the client library, or maybe in the proxy here, or someone has to do the encryption. And I mentioned there's I had some variables here that says key. Where does the key actually come from, right? You could make a key, and key is just a sequence of bits, right? 128-bit key, 256-bit key, and you could put it in a file somewhere, and then it's your key. That's sort of the basic scenario. But what you actually want is a key management system. Those are software components. Many of you will probably have this in your organization already for various other reasons. There's various bunch of commercial products that do this. They just manage keys. And you can use that for all kinds of things, SSL certificates and revoking them, and it does all that kind of stuff, rotation of keys and so on and so on. But you have to connect this somehow, right? And that's, well, it's a simple matter of programming in a sense, right? They have APIs, you call out, give me the key. But all of these key management systems, at least that's my experience, they're all very crafty and weird to deal with, this enterprise software ultimately, right? And they have sort of poorly documented APIs. And so that's a whole another challenge. Whatever solution you come up with, can they talk to a key management system, your key management system? And is that like robust and well tested? And there's actually a protocol, a standardized protocol, key management interoperability protocol, KMIP, which we'll come up with in this context. But that's also terrible. I mean, let me tell you, I think the I stands for interoperability. I have not seen anything that's actually interoperable yet. Very poorly documented, but very widely used. So you still have to basically test each key management system individually, right? Don't be fooled by like, oh, this speaks KMIP, great. No, that's not. So that's a whole another problem space here that we'll come up with in this scenario. So whatever solution you have, make sure it talks to whatever key management expectations the organization has. Here's just some examples of different key management server products. There's different key rotation requirements. So in my sample code here, I have a 2-key architecture. There's a master key which encrypts another key, which is the actual key that's used. That's kind of a common scenario. What's nice about this, if you need to rotate the key, you can rotate the master key very easily because it doesn't actually encrypt any data. It encrypts just another key, which is a very small operation to change. If you need to rotate the actual column encryption key, you have to rewrite your entire database, right? This is the problem with that. So that's why usually any system that works like that, be it TDE or disk encryption in the operating system, they usually have like 2, 3, or 4 levels of keys to make it easier to rotate the various levels of keys, because there's, again, requirements. You have to rotate your key every 2 years, which everybody asks about. Nobody actually ever does, I think. But you have to at least, think about that to have an answer for your auditors. All right. Secure enclave is a piece of hardware that sometimes exists and it does, sort of secure boot and various things like that. But what some also do is that you can load sort of operations into the secure enclave. So you could do operations on encrypted columns because the secure enclave decrypts them. You could do things, and then that's a good idea. It is implemented in other systems that are not Postgres. But again, it turned out that's not secure, because those kind of things leak things. These things nowadays, you can just listen to the CPUs and get bits out of that way, right? Or sort of measure the heat of the CPU, or what people do nowadays, right? So these kind of things are not secure. So that kind of hardware is going away. So that's not really anything that's going to help you practically. Another nice feature idea is that you can encrypt a column and have integrity protection, for example, and that will make it secure as the column. But what an adversary could do is actually swap column values, right, into different rows. Nothing prevents that in sort of this basic scenario. So another thing to think about as, well, that's mainly for me as a sort of a feature. It's kind of hard to implement by hand, to tie these encrypted values via some kind of signature to the primary key, so you can't swap them out. That might be nice, but it's obviously much harder. Anyway, well, let's skip to the end here. We're almost out of time. As an advice, obviously look for solutions that are mature and general and fit your scenarios in terms of compliance and these kind of requirements that we talked about at the beginning. PG crypto, as I mentioned, is almost always the wrong solution. Maybe consider PG Sodium if you want that kind of setup. I think PG Sodium is quite nice. I think the Django plugins, some of them also quite nice. Some of these proxy solutions may be good, but I don't know what's in them, right? I think they make sense maybe, but I don't know what's in them. So those are the kind of solutions I would say are okay. Again, homomorphic encryption is probably dubious. So that's a lot of marketing message often in that. It's like it fixes all of the problems, but maybe not. So I would like feedback. We don't have time now, but maybe during lunch or also, over the next days, weeks, months, years. If any of this is sort of interesting, you have some scenarios, give me some feedback on use cases and what you want to do. And I want to work toward simplifying the space, basically. And I hope I gave you maybe more questions than answers, but I guess that's the situation we're in. That is all for me. We have 54 seconds. I think we're up against lunch, so we can have as many questions as we want.
Yeah. Thank you. Thank you, Peter, for such an insightful talk. I have a gift for you, another electrical elephant. So we have time for one question. Anyone? We have back there. Boris, could you be so kind? Yeah, here it is.
Hello? Great. I had one question. For the built-in patch that you're working on, and where you create the master key and the encryption key, I think one thing I would be worried about is for example, backups. So my question is, how are these stored in a way that an attacker who would get access to the backup, or in another case, an attacker who would have a SQL injection wouldn't get access to these encryption keys?
So the idea there is that the column encryption key is stored in the database in an encrypted form, and it travels with the database, so it would be part of backups and things like that, but it's encrypted. And the master key would be in the key management system, ideally.
Okay, so thanks. That answers it. Yeah.
Okay, so Teresa is getting information there that she needs to share with us in this moment, and then she's going to tell us everything about lunch.
Yes, so, well, I'm not sure if I understood correctly.
All right, I will try it again. I can think about it. Finally, I see Chris in the room. We tried to thank Chris already in the morning, but Chris, you were not here yet. Then I tried to thank you at the start of my talk, but you were not there yet. And now I see you are finally here. So please come on stage, because you did a tremendous job helping us out organizing this event. I think Boris made an announcement to make you the high lowlander of today. And maybe not everybody knows you, so we have some important items so everybody knows who you are and how important you were for this conference. So thank you very much. That's because of your hair, Boris. All right, thank you, Chris. Thank you very much.
Yeah, so now it will be actually the lunch break. But before we go, let's aim to be here back at 1:40, like in 55 minutes. For the lightning talk speakers, please be here 7 minutes in advance, so we have some preparations to do.
It's a very precise schedule.
So thank you so much. Have a nice lunch.
How do I turn this on to blink? Ah, it's very tiny. Okay, thank you. Yeah, I did see that. Also, this was on the timescale platform. But it's generic. No, yeah, but I also saw like Superbase offered it also and also pulled it lately. So yeah, that needs to be researched. Probably the thing is saying, I think it's mostly to do with host privileges. Yeah, but couldn't that be fixed instead of being pulled from the platform? I don't know. Well, we reported it upstream. Yes.
Yeah, the feedback's super good. You know when you say, oh shit, and then you...
Yeah, come closer, farther. Yeah.
Right. Right. Yes, thank you very much. We have sound. All right, everybody. I hope you all enjoyed a typical Dutch lunch. Some people ask me where you can leave the cards for the sponsor raffle. Here on stage, we have the big glass bowl. If you have all the stamps completed, you can put your card in the bowl, and then at the end of the day, we will pick a winner or two. For now, it's time for the lightning talks. For those of you who have never seen them before, lightning talks always finish in time. If we have 5 seconds to go, I will raise one hand. I will be sitting there, and you start clapping with 2 fingers. You can practice. Right? And then when I raise 2 hands, you use both hands to clap, and then the talk is finished, and we start with the next speaker. Thank you. All right, so Floor, you're first. Have fun.
They gave me a microphone, I don't know why. All right,
Hello, everyone. I want to talk about Mastodon a little bit because I think the adoption of Mastodon in the Postgres community has been quite significant. I was wondering if the Bird app was being taken over by the Elephant app. I was wondering how y'all use Mastodon and how we can make it into a platform for networking and support, like maybe Twitter once was to you as well. I know that I'm still mourning Twitter, so I really want Mastodon to take that place, ideally. All right, so that's me. My name is Floor. I'm head of education at Tembo. If you want to learn more about Tembo, talk to me later. And I was lucky enough to get the help of Andy Piper, who is the developer relations lead at Mastodon, so safe to say that he knows what he's talking about when it comes to Mastodon and the Fediverse. All right, so real nice. I asked a lot of people in the community to tell me about their Mastodon use and maybe what's keeping them from using Mastodon even more. So some of you in the room actually have answered my little survey, which is by no means, scientifically sound. It's just a couple of questions that you answered. If you feel like talking to me about your use of Mastodon, I would love to talk to you. So please hit me up as well, and we'll figure it out. But from that little survey, and also from some conversations in hallways at conferences, I found out that a lot of you moved from Twitter to Mastodon when you know who took over Twitter. And the main reason is platform toxicity and sort of like the chaos that unfolded after Melon took over. And some of you moved entirely to Mastodon. Some of you still have a Twitter account as well. I refuse to say X, by the way, so I'm just going to continue to say Twitter. Most of you, in terms of other social media, use LinkedIn for professional endeavors and then hold on to Facebook and Instagram to keep in touch with family members and old friends. You use Mastodon mostly to keep a pulse on what's happening in the tech community in general. Use Mastodon specifically also for the Postgres community and figure out what's happening in Postgres. Most of you are on Fosstodon or Mastodon.online or Mastodon.social or Hachyderm. You lurk daily, but you post a lot less. You post a lot less than you used to on other social media as well. And reasons for that is that you feel like there's not enough engagement on the platform. Maybe that's perceived engagement, but we'll come to that. You feel like it's not serious enough, like very few organizations, companies are on Mastodon, so you feel like maybe it's not quite there yet. And there is a lack of an organized topic stream. That's also what you mentioned, why you're not as active on the platform. So, Postgres community is not known as one to switch tools or approaches. We're still stuck with mailing lists and big hairy releases, for better or worse, but that makes sort of that makes people picking up Mastodon so quickly quite remarkable. Discoverability is definitely an issue that you cite, and there's actually some solutions. So you can actually use hashtags on Mastodon. A lot of people still don't know that, but it's actually really, really helpful to find some topics that you're interested in. You can create lists, much like on Twitter, only you need to follow the people, and that's maybe like a little bit of a burden or like a boundary to access. You can actually follow people on threads from Mastodon. Don't know if you know that. Only if they have Fediverse sharing on, and only when you're not living in the EU, so maybe not as applicable to this audience. You can follow people on Blue Sky, did you know that? But only if they have BridgieFed turned on, and they can see your replies and reactions as well. They cannot reply to you, though, not yet. Maybe that's coming as well. Also, fun fact, some Mastodon admins are actually Postgres users. So I'll share a link in the resources slide where a Mastodon server admin actually used PGRepack to delete some dead rows and create some space on their server. So that's pretty cool. All right, in terms of tools, there's really cool tools out there, so you don't need to go to the website or the web app. For apps for mobile, you can use on iOS, you can use Ivory or Ice Cubes. On Android, you can use Tusky. You can use Buffer if you need to do some professional mastodoning, like I need to do as part of my job. You can actually use Buffer now, or you can use Mixpost if that's your thing, if you don't want to pay for Buffer, which is fair enough. You can create a Fediwall like we have here on the back. All right. I'm happy that we have a healthy platform now. Let's make it a lively one too, yeah? Let's all go to Mastodon.
Okay, Floor, thank you very much. Onwards.
Hi, I'm Albert Hofmans. I'm a GIS consultant at Alliander. Alliander is the largest distribution system operator of the Netherlands, and I'm going to tell you a bit about how Alliander managed to do a large amount of projects with data stored in PostgreSQL and with two extensions called Foreign Data Wrapper and PostGIS. The total length of our electricity grid is equal to 2.5 times the circumference of the Earth, and the length of our gas grid is a bit more than 1 time, and 90% of our grid is below ground, underground. In the next years to come, we have to do 5 times more work as we did in the previous years, and the amount of work results in 7,000 projects a year. In preparation of the projects, we have to check for the environmental impact, and for that we have to look at the websites of a lot of authorities, and here are a few of the logos. You can see that there are 139 municipalities we have to check. Our engineers have to open each website one by one and check visually if we are within the preliminaries of the set by the authorities. And if this is the case, then we have to apply for a permit. And each authority has its own time to respond to our requests. A few of the analysis we have to do: are we within a certain distance of brittle pipes? Do we cross pipes of the Gazuni? Do we cross a plot with a monument on it? And that's quite of a geo-analysis. For this, we created a solution, the QuickScan solution. And the QuickScan solution has 2 entries. The first one is you select the project in the QuickScan solution. The information is sent to the service via API. The Postgres does the analysis and sends results back to the QuickScan tool. QuickScan has a database behind it with a knowledge base, so they can calculate which permits we have to apply for, and also how much time it will take. Some of the permits take about half a year to get it. The second one is if the engineer wants to check the information itself, he can start Spatialite. The GIS application is opened, and he sees on the right side, it's very small here, what the impact is. It's also possible to do the analysis direct in Spatialite. In that he can create a rough sketch of the project he's going to work on, and direct he sees what the impact on the environment is, also using PostGIS. Or he can recall the data of an existing project, and analysis is done. Here you can see in the blue lines, I don't know if it's very clear, these are the pipes who are going to be laid the next few months. The other thing is the Foreign Data Wrapper. To speed up the process, we did download the information from publicly available sources, processed it by hand, and put it in our Postgres database. And now we have a data as a service subscription of Spatialite. They do the pre-processing and the gathering of the data. We do we put the data in our own format, and with Foreign Data Wrapper, we can download the information in our own Postgres database. Why do we use Postgres and PostGIS? Alliander is a smart follower. We maintain a power supply for 5.8 million customers, and we cannot afford the risk of adopting new technology that's not proven. So we only adapted Postgres, I think 2 years ago. And because now it's stable, it saves a lot of costs compared to the Oracle license costs. Alliander has also a policy to use open sources as much as possible. Postgres covers most of our use cases, and PostGIS covers most of our use cases too. Is it so?
Okay, perfect timing. Beeldje.
Hi. Okay. Thank you. It's already started. Today I'm going to talk about the conferences that we have been doing for the last 2 years, Diva Dive into AI conference, and how we pioneered the inclusivity at the conference. Okay, first team. This is our team. Daytime, they're tech worker. Nighttime, they're working for the conference. Gülçin, me, and Ayşe. Okay, I said it. It's we have this conference for the last 2 years. We started with 10 talks, 6 workshops, and this year it was 19 talks, 5 workshops. And attendees, it was more than 50, I think, last year, and this year it was more than 600 people have attended. What about the women speakers, right? How many women speakers we have in PGDay Lowlands? I don't know. But the first year, we had 9 speakers, and 7 of them were women. And this year, we had 26 speakers, and 20 were women. I'm going to get how we did it. And what is the secret? First thing first, it's 3 women is organizing. It's the diversity at the beginning, I think. People don't afraid. Also, we reached out to the people in underrepresented communities. It's not only women. I'm talking about for people with disabilities as well. And we try to give some small gifts to make people talk because people are shy to talk about, to ask questions. And the accessibility aspect. We chose a venue. That's great for kids. That's great for families. So, it was the first thing that we have did. And we made sure that our website is accessible. We had some consultation from a company called Be Inclusive. They released an extension, a website extension for us, and we used that website extension so that we made sure that everything is accessible for every single person. Then, we had so few money, but we hired 2 sign language translators. And 2 sign language translators made sure that people with disabilities can listen, can learn as well, can attend to the conference with no disability for them. And we focused on, even while sharing social media campaigns, social media posts, we made sure that we're writing alt text because it is changing a lot for them. So we tried to give some small support for the travel and accommodation to the students. Also, it was free. Free admission means financial accessibility as well. And we made sure for the assistance for disabled speakers and attendees too. And the inclusivity part. Okay, last year as well, we did this. We agreed on with ICT teachers, and ICT teachers gave hands-on workshops for the kids for AI workshops. And then we made sure that for the food, we're providing vegan, vegetarian, gluten-free options for food for the people. And then for the parents, right? I don't see kids in here, but we invited them, and we provide and made an agreement with Oyun Istanbul. In Istanbul, Oyun Istanbul played with them, played with the kids, while parents have the fun in the talks and workshops. Then, of course, like PGDay Lowlands, we also record and live stream the event as well. And we're looking for sponsors for the next year. We already have started working, so please feel free to reach me out, or you already know, I think, Gülçin as well. Thank you. Also, Gülçin have released what we did different in GitHub as well, so you can check the GitHub too. Thanks.
All right, Teresa.
Yes. Okay, let's start. This will end on time, I promise. So sooner or later, every one of you will be at one of the ends of this question. Why is my database so slow? You might reach for some help, and yeah, well, it might not be very helpful. Anyways, my name is Teresa Lopez. I'm a database engineer at ADN, and I will show you how you can scale your database. Prepare your photos, because that's it. It's here. That's done. But before we start kind of throwing money at the problem, maybe we can start asking, why exactly do we need to scale our database? Identify your bottlenecks. Understand what type of workload you have in your database. Have you checked your database configuration parameter file once, even? Or are you still using the defaults? Do you need to scale because you have a new product, a new feature? Are you expecting more traffic into the database? The answer to all of these questions will probably lead you to one or more one of those squares I presented before. Also, this is not size fits all so kind of thing. So you might have to combine solutions, and some of them might not be at all for you, let's say. So let's start. First one, just buy bigger machines. It should work, right? At least for some time. But let's continue. Today, lots has been said about replication already, so why has your primary database take care of the writings and the reads and everything? So maybe you can split the reads into something else. This is a bit like you have a big problem, so let's try to break it into smaller problems. So we have massive tables. Let's just break them into smaller and more manageable ones. Every one of these things has pros and cons and some things to consider. Here, I would say the major thing to consider is the major challenge is actually picking the right partitioning key, because it's not very easy to kind of change after the thing is running. Same approach. Big database, why don't shard your database? If you have a customer's database, maybe we can have a shard with customers that start with letter A, and then the second shard with customers that start with letter B, if that fits your business. Just be aware of this little thing. It's called the Bieber bug, so before you start sharding your database, just Google it, please. Anyways, when was the last time you look at your query plans? Maybe just like the top 5 or top 10. Maybe look at them. Check if you have index in place. Check if they are the most useful ones, and delete the ones you don't use. Because every time you update data, indexes might need to be updated as well, and it just takes time. So next. Materialized views. Yeah, if you have these big aggregations, reports, and so on, consider creating materialized views. They are similar to views, but they are stored into disk, but they do need to be refreshed. So take that in consideration. This one, I think it's not very consensual, but if performance is all you care about for your queries, this might be one option. Just be aware that denormalizing your data model or some of your tables can put data integrity, data consistency at risk if not done properly. Next. Add a caching layer between your database and between your application and your database. So instead of all the queries go to the database, they might go to the cache and get the answer. The biggest challenge here, I would say, is to define a proper time to live for the cache. And again, this might not be suitable if you have a high update kind of workload, because the data changes so much that caching might not be the answer. Last not least, and my favorite one, is clean up your database, please. Delete what you don't need, archive historical data, keep your database tidy, check if Vacuum is doing the work, and that's it. That's all I have for you today. Haha, I finished on time. Yay.
Hey, Michael, you're next.
All right. So if I were to ask you if security is an important topic for a database, I think I would see all the hands up, but we don't have time for that today, unfortunately. My name is Michał Nosek. I work at Percona, and I'm here to talk about transparent data encryption at rest in Postgres, or TDE in short. And I'm going to tell you today 3 things: why this is important, how we address that with open source PGTDE extension, and why it is important move for Postgres community and win for everyone. So what is TDE? TDE is basically an encryption that is encapsulated in a database, right? So it's managed by the database, it's transparent for the applications, and it's basically about encrypting what is coming from the shared buffer to the storage media and decrypting when it comes back. It is also including key management, and it's very important not to mistake that with storage encryption itself. So the encryption comes from the need for encryption often comes from smart technologists who actually know that it's not a good idea to have unencrypted sensitive data stored anywhere. But industry actually doesn't rely that much on the common sense anymore, but there are some well-defined standards that require from you to have encryption. And you would say, but hey, Postgres already have different methods to encrypt your data, or you can simply encrypt your storage, right? So why encrypting your storage is actually not enough, or maybe it's not favorable in all cases. So there are 2 groups of reasons why TDE, well, is in some cases better than just storage encryption. Some are technical and some are non-technical, as you can imagine. And when it comes to technical reasons, first you can choose what to encrypt and with what keys. So for example, separate databases with different keys. Not sure if you knew, but one of the most common exposure vectors for the databases is public S3 buckets with physical backups stored there. And actually TDE would save you from that to some extent, at least. It is also independent from storage, so it's in the control of the database teams, and it adds defense in depth, which basically means more layers of security. The more you have, the better. From the non-technical perspective, compliance, this defines in a pretty generic way how encryption is needed, but then you have compliance teams in your organizations or your customers' organizations that interpret that, and believe me, they often want to have TDE as a preference or even as a requirement. And I also talked about data breach consequences. But if you don't believe me, our founder, Peter Zaitsev, did some survey on Twitter or X some time ago, and majority said that it would be nice to have TDE in Postgres, or you can open dbengines.com and see which databases don't have TDE out of the most popular. TDE is not a new topic in Postgres. There was some patch in 2016. It never made it to the core. But the market demand is actually clear, because you would see so many proprietary implementations of TDE forcing some organizations to actually not go with open source Postgres, but with the proprietary versions of it. So I would like to introduce you to PGTDE. This is an extension, not the core modification, and it basically introduced encrypted access method. It's coming with MIT license. It's developed by Percona, and currently it's in beta. You can check GitHub with this QR code. So what does it encrypt? User data tables, including toast tables, write-ahead log, temporary tables, and indexes. But there is a catch, because it cannot currently encrypt indexes with Postgres community, and the reason is that we basically need a patch in Postgres storage API. So we have 2 builds of PGTDE for the time being. One that is working with Postgres community, and another that is working with also open source Percona distribution for PostgreSQL. The difference is index encryption and some performance improvements there as well. If you want to use that, it's pretty simple. You just use TDE heap access method or TDE heap basic access method if you're using default Postgres storage API. And it has a couple of other interesting features that are important typically for large organizations as well, which is multi-tenancy with separate keys per database, table-level granularity, key rotation, and key management solutions integration. So I would like to leave you to leave this lightning talk with 3 things. TDE is important encryption method in addition to other methods. There is PGTDE extension available out there. It's open source. You can try it. And it's a win for Postgres community if this is implemented, because basically that will allow more workloads and more serious workloads to be migrated to open source Postgres as well. Last but not least, Go ahead and check it, give it a try, stay active, share feedback, and contribute. Thanks.
Okay, thank you very much. Last but not least, Evan.
All right. Hello, everyone. My name is Evan Stanton, and today I speak for the brain. You know, at times the brain may seem a bit self-serving. You know, it's the only organ that named itself, and while I was at it, self-proclaimed as the most important. But while offering credit where credit is due, there's plenty that we can do to help this executive operator perform well. And so similar to the story of the Lorax by Dr. Seuss, I believe that there is a valuable resource that is being mistreated. And today I want to share with you all why that matters. So who am I, and why is it worth listening to me? To start off, I spent about 8 years in academia as a neuroscience researcher, where I contributed to publications in the fields of cancer, behavior, and brain waste clearance. As I became more involved in projects, I fell in love with data and data management and transitioned into industry, where I now work with Tembo. Having made such a jump, I'm eager at the opportunity to share with you all some of the learnings that I took away in the hopes to make the Postgres community the healthiest community. And so with my remaining time, I'll speak about one of the most important things that we can do, sleep. So I can imagine that the majority of us would agree that a good night's rest is healthy, but at the same time, I would also imagine that the underlying biological mechanisms behind it are a little bit less well understood. For example, did you know that every time when we sleep, the brain rinses itself of the naturally occurring metabolic byproducts? This also happens during the day, mind you, but it's much more performant when we sleep at night. The brain and the spinal cord are bathed in a fluid, aptly named the cerebral spinal fluid. And what happens is that it travels alongside the arteries, goes into the brain, does its thing, and then leaves the space and is processed by the rest of the body. While I can't really go into details, this is known as the glymphatic system and has implications in aging, Alzheimer's disease, stroke, and so on. This is by no means a stagnant system, and there are plenty of things that can help or hurt it. Here's a non-exhaustive list. We mentioned sleep, but its antithesis isn't necessarily wakefulness, but rather sleep fragmentation. Exercise can be very helpful, but chronic stress is very hurtful. And studies do suggest that a very small amount of alcohol, hear me out, could be okay, but large amount short-term and even a small amount frequently is worse than baseline. And so anyways, alcohol is bad, so please afterwards don't go to your doctor and say a guy at Postgres told you it was healthy to drink. That'll get me in trouble. So that all said, I'm not here today to tell you that the way you're doing things is correct or incorrect, but to rather offer you some potentially value information that you may not have been aware of beforehand. And to tie it back to the beginning, explain what I meant by feeling that there's a valuable resource being mistreated. Our brains are the only ones we've got, and in today's fast-paced, high-tech society, it's easy to treat it as a second-class citizen, or even be upset at it when it doesn't act the way we'd like it to. Each company and team has its own cultures, rituals, and status quos that may very well be beneficial, but sometimes it does benefit to take a step back, to ask oneself, is it healthy, helpful, or even necessary in its current state? So take care of yourself, take care of your team, take care of your employees, and if you haven't read The Lorax by Dr. Seuss, I strongly recommend it. I've included a number of resources in the appendix of this talk. And to end with the question, what would the Lorax say? Thank you very much.
Okay, Evan, thank you very much. Please stay on stage. You can put the clicker over here. Can I have the other lightning talk speakers as well here on stage? Please stay, Evan. Because giving a short talk is in no way any easier than giving a long talk. So, you're giving them to me, and then I feel like the man in the middle here. We just share the load. Thank you very much. There you go. Okay, big round of applause, please. There you are. I lost you for a second. Okay, next one, Jeremy, who does not only know a lot about Postgres, but also about operating systems, Linux operating system in general, I think, and middleware. And today he's here to share some of the horror stories he encountered over the years. Thank you very much, and give him a big round of applause.
Technical difficulty, of course. Yeah, hopefully I can fix it. Yeah, you're right. Yeah. Tu veux un truc? Oui, il faudrait que tu me montres comment tu veux. Okay. F11. Et là, attends. All right. Backups. Okay, I can start right now. Okay, that's why backups are important, by the way. You see? Okay, so I hope you love stories as much as I do. And in fact, scary stories in production, no less. So let's go. Before that, of course, we're talking about my company. We do T-shirt too, like many. So I work for Neox, it's a consortium, several companies. A lot of companies are software developers. We host everything ourselves, so many Postgres databases, ranging, I think, several thousands. Some are pretty big, some are little databases, but we have a lot. We mainly work in healthcare, so data are important, data are personal data, so of course we take security seriously. Myself, I'm the head of infrastructure. I began to work with Postgres 12 years ago now. Today I am manager, but I still try to keep a strong technical proficiency. And I love Postgres. And sometimes, not every day, but sometimes I'm called to help some partners or customers that have a pretty serious incident in production. And thanks to them, I can do this presentation. So thank you. And you'll see. So when you are called in another infrastructure that is not your own, you need to be very methodical, especially when there is a big problem. So every time I try to apply this. First, problem identification. Most of the time,
you'll see the first sentence you hear to have the problem, the description of the problem, is not very clear. So you have to find out this and do some digging and find what is the problem exactly. For that, you need the environment. It's not your own, so you need to look around, see how it works. Do a diagnostic, of course. Find a solution. That's why we're here. And here I will give to you the takeaways, because when we see problems, that's when we can learn from them. That's what's important. OK. Before we begin, we are gonna steal one directive from Robocop. We will not serve the public trust, nor uphold the law, but we will protect the innocent, so I will not do any name dropping. All my case will remain anonymous. OK, so first story. So that's the only sentence I got for this case. So my customers are not always sorted the same way. Why is that? There was some spoiler this morning about this case, but let's go. First thing, we need to know the environment. So it's a classical environment with an application, a primary, a replica. If you remember, we had we had Dev and Dirk that did something about that. So that's the same. And between them, it's a physical application. So the read operations are balanced between the primary and the replica. Sometimes they use the primary, sometimes they use the replica. It depends on the application code, actually. So what do we see? It was a strange problem. Sometimes the application did return some result, sorting in some way, and sometimes in another way. So we tried to do the sort directly in the database. On the primary, of course, this is a reenactment because this is confidential information, but you see, we do sort. And then on the replica. Notice some difference? Something is not right? Or is it possible? The sorting is not the same. Shh. OK, so we need to know a little more. How can it be? So let's look at the operating system and how it works. It was, before the issue, it was like this. 2 Debian, same version, same Postgres version. Like I told you before, it was a physical application. Everything was working. Then, the problem is the company decided to change it, but the wrong way. You'll see. This way. So actually, the decision was to use a FreeBSD, which is fine. FreeBSD is fine for all Postgres cluster. But to do that, they just began by the primary, and so what do we have? We have people that don't read the PostgreSQL documentation, basically, because we know, you should know that you must have the same OS when you are doing physical application. So why exactly? Because the collection is different. And in this case, it was even more different. It was UTF-8 on the Linux and C and FreeBSD. So for those who don't know, but we can talk about collection this morning a little bit. Collection are the set of rules that determine how text strings are sorted. So this is critical mismatch because it will lead to index corruption. In fact,
since the data is sorted differently, you can insert duplicate data, for instance. So, yeah, pretty bad. How did we solve this? Any idea? That's a bit of this. You have to move the cluster back to the same OS. You have to select one. And you have to reindex every index that has a collection. And then, of course, since it did work, I think for 1 day in production, you will have some issues because some data will be duplicated because of the index corruption. So at this time, it's you need someone that has knowledge about the application that can correct those data. And it can take some time. So what did we learn from this? OK, it's in the documentation, but same OS for physical replication. And but there is something new that will come. In PG17, you have a new collection, and CUTF-8. And it's very interesting because it's not tied to the OS, not tied to glibc. It's directly in Postgres. And if you want to know more, I cannot stress enough. You look at this conference that has taken place in Vancouver this summer. And you will see how to use this collection. It's even more, it's even faster than the classic UTF-8 collection. But it's only PG17. OK. Next case. Again, great description. From time to time, the application is slow. OK, this can be basically anything. First time you have a customer that tells you that, you just say, check your internet connection, should be it, and don't bother me. This time it was a real issue. It was some time, but not all time. It was not very clear. So what do we see? At this customer, monitoring was not very good, monitoring tools. So we just, in the end, I just got to the server and run hashtop. And I saw this. Yeah, I think even there is more. So, but a little problem. The load is a little high, but it's something is wrong. Let's look at the process. OK, everything in startup. Oh, there is another vacuum. Something is working. There is a lot of them. So the server is not doing any work, by the way. At this point, it's just a starting connection, and that's all. The first thing you think when you see that is there is no puller. Maybe something is just opening and closing connection, and whatever. But it was not the case. There was a puller. The puller was a JDBC. But if you misconfigure a puller, you actually have the same, it works the same way as if you don't have any puller. Because you can just pull until some point, then you will try to open more connection, and it will open, then close because you are outside the puller. And this is what happens. Every hour, the application was, of course, most of the time the application that is a culprit. The application was running a task, which was opening many connections, and it was just crashing the whole production. So what do we do? Fix the application. Easy. Yeah, right. It's not always possible. As DBA, you should know. So we have to work around this. Configure the puller correctly is very important. That's it. And also, I didn't see this in many shops, but having a connection churn monitoring to see the rate at which your connection is created and destroyed is important. It can help you catch this. And lower the max connections. Because if you work with developers, I have nothing against developers, but they will just say that they want more connection. More connection, more connection. Yeah, I need more connection. But they don't realize that every active connection will use a thread. So if you open like 1,000 connection, I don't think you have a server with 1,000 threads that can work with this. So, third case. The server is overloaded. This was an operator, so I did trust what he said a little more than a customer. But still, there was some monitoring in this case. So we have graphs. Nice, all right? This is a graph when everything is working. Everything is fine. The load is fine, so. And this is Monday morning, the next week. Again, notice some difference. There's a little red, but maybe it's just here for colors. Nice, right? No. And the connection? The blue are active queries. So it's not normal. You should not have so many active queries at the same time. I think right there, it's just they restarted the application to see if it would fix the issue. Did not. So, investigation. This was kind of hard to catch. I did arrive a little after they began the investigation, actually. So we tried a lot of things. PGBadger, and when you set PGBadger with a duration statement to 0, you know something is wrong, because you're going to have a lot of logs to analyze, and it can take a lot of time. When you have more than 1 hour to just run PGBadger, that's bad. Then explain analyze of the queries, vacuum, analyze for table, bloat estimation, like we saw this morning, it's not easy to have a correct bloat estimation. We actually caught a lot of things here, but that was completely irrelevant to the issue. But we tried a lot of things, and it didn't solve anything. The database was always overloaded. So it was live production, a very big customer. So at this time, you begin to want to fix the thing anyway, even if you don't know what is why it doesn't work. It feels a little like this in this case, where you are fixing a plane while it's in a war. So emergency fixes. I am not very proud of this, but desperate time, right? So we killed some statement every 2 minutes to prevent this. And we began to create a test cluster to replicate it. Oh, that's good, but most of the time, when you are in this situation, you need to take a step back and see the bigger picture. Because something doesn't change overnight, or maybe. We were Monday morning, and maybe something happened the night before. But we didn't know at the time. But I had my suspicions. And of course, there was something. So in fact, it was just a minor PostgreSQL upgrade. But it did use a new system to deploy the configuration. Interesting, no? So I did look at the configuration itself. Like every settings, but it was pretty quick because I saw this. So the value before was 32 gigabytes, by the way. So turns out if you divide your shared buffer by a factor of more than 4,000, some things don't work as well. This is 32 gigabytes. And can you find the 8 megabyte here? It's here. Yeah, it's right there. So, yeah, that's a big factor, you know? I think it's not even... yeah, I think 8 megabyte is even... it should never be... Even the dot is too big. So, yeah. So how to avoid this? OK, of course, better deployment process. And the second one I love because the teams didn't talk between them. So the team changed things, doesn't say to the production team that it changed. That's why. But monitoring a PostgreSQL configuration value is something that is a good idea also. Most of the time you have monitoring of performance, CPU, disk I/O, everything. But configuration is not often, I didn't see more often the configuration in a monitoring system. And it can be a good idea. And by the way, it was incredible that the production still worked thanks to to Linux cache. File system cache did make it work. And this is actually pretty amazing because with 8 megabytes of shared buffer, I would think that nothing would work. But it did. OK, then. Too many simultaneous active connections. And this is very accurate because it's a monitoring system that says this. So, a little background on this. We have a big servers. We talked about servers with many threads. This is one of those, a big beast with lots of CPU, lots of RAM, lots of disk, but also lots of databases. Around 600 databases per cluster. That's a lot. Every database is linked to one application and one application to one customer. OK, that's a lot, but it did work fine until... Oh, still, you see some blue? Too many active queries. It looks like the other case, but it's not the same. And it happened one time and doesn't let go. still keeps all those queries active. But what are those queries this time? OK, who knows what is a subtrans? Yeah, subtransaction. OK, so when you, there's again a lot of them. I did truncate it because there was thousands of them. But yeah, PG activity. When you have a PG activity, PG stat activity like this, again, nothing is working. It's completely stuck. You have substance. And if you don't know what it is, I think the first thing you look at is what is a substance. And it's actually, yes, it's a subtransaction. So a subtransaction is a transaction that can be started from another transaction. It's created by save point and exception. And even more fun, you can start a subtransaction from a subtransaction. And so on. You can have several transactions that are build one on the other. I thought that safe point and exception are two keywords that we should play with Pavlo and Wordle. That's a fine one. And what's interesting in subtransaction is that it uses its own cache, a SLRU cache, a specific control lock that is different from the other transaction. And of course, we have a documentation about them. But here the problem was there was too many subtransactions. And when there is too many subtransactions, we have subtransaction cache overflow. And because of this, the cache cannot has a fixed size, and you cannot change it until at least in the current stable version of PostgreSQL. And we'll see why I'm saying stable right now, later. So, since we have cache overflow and we cannot change the cache size, how can we fix this? There is basically only two fixes possible. Again, fix your application so it doesn't use so many subtransactions. Or you have to reduce the number of databases per cluster. So you basically you will cut your cluster in two, and you will have half the database on one cluster, half on the other, and you will double the cache, the subtransaction cache. So currently, that's the only way to fix that. And it's very difficult to catch because everything is working fine until one day this happened. So it's very important to be aware of subtransaction because it can catch you by surprise, and it's very hard to diagnose. Anyway, this is a fix. This is current fix. So know that subtransaction exists because I think no developers I know knew they exist. And there is no way to change the cache before PG17. Again, very good release. Not yet stable, but soon. And again, there is a conference in Vancouver that was about how it was changed in the PG17. Now you have, I think the size is proportional to the shared buffer, and you have buckets. So the lock is distributed between several buckets. But if you are not on PG17 or you cannot switch, you're going to have to be aware of this issue. OK. Other case. Everything is crashed. So it's not fire related. I realized when I put this background, but it could be. So when everything is completely crashed, you just think, most of the time, I'm OK with that. You just have to connect, see what goes wrong, and restart the process. It's kind of easy. Other cases, when you have to look for transaction stuck or whatnot, can be complicated. You know, usually, it's easy. So you just have to connect to the server. Or can you? OK, so no SSH, doesn't answer to ping. That's the primary. There was a replica. Let's go to the replica. OK, that's different servers. OK, no answer. OK. We can still use IPME and see on the server what is actually happening. So let's go. Very clear. We can. I don't know about you, but I did not understand what was going on at this point. It's, I think, yeah. When you see that, it's a real output of the server this time. You say, OK. Maybe on the other server? No, same thing, of course. OK. So in IT, there is a solution to this kind of problem. A universal solution. We all used it. Exactly. Just restart it, reboot. Everything will work. Right? Maybe. So, before I give you what happened next, I will tell you of the environment. So, before NVMe, you know, the SSD drive, we had those kind of beasts. There was PCI SSD drives. So they are connected via PCI. They were the fastest SSD on the market, cutting edge, really. Very expensive. And they did basically embark their own operating system. They were very smart about this, and they used proprietary drivers. And they worked fine. And this is what was used in this case. Also, both those servers were not too far away from each other, you see? So maybe something is related, and I will tell you why. It's because the network was too slow for replication. So they just put fiber optic cards in the servers and linked both of them directly for the replication. Why not? It was very fast replication. But after the reboot, it was not working better because we had this, and after 2 minutes, it did reboot. So it was rebooting in a loop for both servers, and there was basically nothing we could do. So at this time, I think it was several hours of downtime already, complete stop. And I began to look at other ways to solve the issue, like backups. Because in this case, you really want to backup. So you ask, do you have a backup? You're always afraid to ask this question. But yeah, afraid of the answer, exactly. So you don't want to have to ask this question. And this, here, I was surprised. Yeah. All right. All right. Great. Can we have access to the whole repository, for instance? Sure. OK, 3 days worth of walls. Perfect. Maybe we can restart production on another server. Can we have access to the PG bus backup or something, a file system copy? You know? Yeah, sure. I don't know about you, but usually I don't call PG bus backup a SQL file. But at this point, I was still hoping that it was just poorly named. But no, it was not, unfortunately. And why? Why in this way? And why? We'll give you one picture. Maybe we'll understand why. We all recognize it. It's our best friend, I guess, that is trying to masquerade as a Postgres. So yeah. OK. There's always it's always a magical moment where you have to say to your customer that they don't have any point-in-time recovery at all. And then my customer actually said, OK, can we use the dump from the night before? That's a good idea, except your system crashed just before the dump. So you don't have the dump from last night, you have your dump from the day before. Do you want to restore and lose 1 day of production? That was no. But don't worry, it ended, it was an happy end. Because at this point I did go back to the actual servers, and I did try my best so that it will stop to reboot in a loop. And actually I found a way so that the system could take its time, and actually it did check on its internal custom file system in the card, the specific card, and it did work, and everything was back. So, believe me, after that, they had the proper point in time recovery. So, key takeaway. It's amazing that it looks like I'm always telling the first sentence. Always test your backups. I've been saying this for at least 20 years, but it's always it's the most important thing. And if you can, don't put the primary on the replica. Don't use proprietary hardware if you can. It's not always possible. Life is better this way. Just use NVMe if you can. Okay. If you didn't listen to me because I have a poor accent or anything, this is no. You can look. I have a bullet point. Everything. So, summary. Collection are able. Yeah, but new one. The new one is fine. Oh, more collection. Yeah, one more standard, right? Yeah, collection can be ever. We did a lot of tries actually, because there was a collection linked to the OS, ICU collection also. I don't know about you, but I never saw ICU collection used in production. Maybe the only one. And now there is a CUTF-8, but CUTF-8, actually I believe in it. It should be really good. So monitor connection, monitor Postgres configuration, sub-transaction. You need to know that they exist. And again, PG17 will add a custom, a way to customize the sub-transaction cache. So very good. And again, backups must be tested. A backup that is not tested is not a backup. And that's it. Then, more generally, your Postgres issue may not be a Postgres issue. It can be something completely different. Because the last case, I showed it to you on purpose. It's not Postgres' fault at all. So you need to do post-mortem, learn from them, and not fire the guy that did the mistake, because he has value, you know. And yeah, that's true. And it's actually it's difficult because when I come at a customer, I'm like the firefighter, the hero, but people, they didn't mess up on purpose. It was not their fault. Most of the time, it's the organization that didn't give them the keys to answer correctly to the problem of the company. So master your stack, of course, but you need to be in a company that will help you do that. Expect the unexpected, because you can learn everything. You cannot learn everything, in fact. You will always, Postgres will always find a way to surprise you, and IT in general. And like I said, communication is very important between teams, especially in big companies where teams are in silo. If they don't speak between them, you will miss and lose some key information. Okay, that's it. And if you have stories and you are okay
to share them with me, I will be very interested.
Okay, thank you very much. Nice stories. Are there any questions for these stories? Yeah, one question over there. Where's my other mic?
Hello? Yes. You mentioned, now it's working. You had a mention about the threads in Postgres, but I think that you meant to say the processes, because Postgres is a multi-process program.
Yeah, sorry, I was talking about CPU threads, because I'm a sysadmin at first, so I'm always thinking of the usage of the system in terms of threads. But of course, yeah, you're right. It's process in Postgres. The project to, well, the discussion about threads in Postgres is still underway, and it's
going to be underway
yeah,
for a long time yet.
It's a big project that will take many years, and yeah, it's not here yet. You're right.
Okay, thank you for this clarification. Do we have one more question? Oh, far in the back.
I was intrigued about the, I think it was a 32 gig VM and an 8 meg shared buffers. One of the reasons I was intrigued was because it's not actually the first time I've seen that. And I was like, how does it work? Because you would think it would be unstable, but it's not.
Yeah.
Is there any upside, like your master is no faster than your... It pushes to replicas. That's what I was thinking, because it was like... I didn't touch it. It wasn't, no one was crying, so I left it like that. But it was like, you know, it was a very similar configuration, 8 meg for the shared buffers, and it was a big VM.
I can tell you that replication was working fine during this issue, no problem. Some queries were failing, actually. I think some queries needed more than 8 megabytes. But other than that, it was slow. But it did work. That's still amazing for me. Yes?
So, sorry, just to clarify, I was not aware of anything failing. I heard that there were some performance problems, but it wasn't enough that actually anyone wanted to change anything. So did you say queries were failing as well as being slow? We did have slow queries.
Failing, yeah. Sorry, it was some years back. But, I think some big queries didn't work at all. And I need to double check that. But yeah. Oh yeah, you're right. That should be it. There was a statement timeout.
It never fails. And, definitely Postgres is remarkably resilient.
yeah. So that may be the statement timeout that did kill them.
But like it never finished.
Yeah.
Okay, last question. No final questions? All right, then we break and we continue at 15 minutes past 3 o'clock. And there is a sponsor raffle at sponsor EDB. I think they're having some prize for if they scanned your badge. So if they scanned your badge, please check out. If you're not there at the raffle, then you can't win anything. And once more, one round of applause for Jeremy. Thank you very much. Okay, thank you very much for being back in time. We are starting right after this break with Julien. He might have listened very carefully to Floor's talk because I understand he's a Mastodon fan, just like he shares liking metal with Boris. But for now, let's see what the story is today. Have fun.
Thank you, Dirk. Okay. First of all, I'm glad to be here, and I would like to thank the organizer for choosing me. It means a lot to me, so I'll do my best. Today I'm going to talk about time series and how to manage this kind of data and our experience at work. So it's a real-world feedback of what we have seen on the field. So who am I? I'm Julien Ryu. I'm an open source DBA since 10 to 15 years now. And you can see my website. There is a link here. My slides are already available, so if you want to follow the slides, you can click online. And I'm also available on Mastodon. And I love Postgres. And also, I have a t-shirt of Timescale. Speaking of that, I'm not a Timescale employee. I'm just, we don't have partnership with Timescale, so this will be an impartial feedback. We did a test on our own, and we will show you the result here. And a little bit about the trademarks, because this is an important topic. I will try to follow the rules. Timescale and Timescale DBs are registered trademark as well as Grafana. So who we are? We are a OVH Cloud, a cloud provider. We have various services, but the point here is that they all rely on critical databases that runs on Postgres. So my team and I are mainly managing the internal databases, not the stuff we sell, the stuff that makes the service run. I will start with speaking about the basics, so everybody will know the terminology and the concepts. Then we will deep dive into three projects happening at various times. So the first one, there are order, so the metrics, Zabbix, and billing are projects happening in that specific order through multiple years. Then we will end this talk by speaking about version, how to upgrade, and some tooling we have created at the very end to make it easier. So Timescale DB, what is Timescale DB? Timescale DB is an open source time series SQL database designed to run time series workload. And it's packaged as a Postgres extension. So it's not a code which is included in the core, it's packaged as an extension. But what is a time series? A time series is a mathematical concept. I will simplify it because I'm not a mathematical speaker as Pakhuis is. So this is data points over time. The easiest way to represent a time series is to create a graph. So I took an example, is the evolution of the number of stars on GitHub, the projects, the Timescale DB project has. So you can see the curve, the line. This is the evolution. You can see trends with a time series. And for DBAs out there, we can represent them in tables, where the key here is the time data. Here is the date, but it can be a timestamp or something time-related, and a value here, the number of stars. It could be any value. The important thing here is to see the evolution. So timescale.db has multiple features. We can talk about partition management because we will see that we have very big tables, compression to save some space. There are a lot of aggregation tools to make aggregation run faster and in a more efficient way. And there are also job scheduling capabilities to make the DBA's life easier. So first, the partitioning. So imagine you have a big table that's so big that is not manageable. So you have to split this big table into multiple smaller pieces. In the timescale.db terminology, the main table is called a hypertable, and the partitions are chunks. So chunks are a subset of the data based on time, in multiple time range for multiple chunks. The compression feature is kind of special because when we heard about compression, we think about gzip, the bzip, and the usual compression algorithm. Here, it's not only the compression, but it's also representing the data into a columnar storage before. So we go from this, a table with 2 lines, to that, a table with only 1 line with all the columns aggregated or collocated with a simple key. And over that, there is some compression happening on the values themselves. So we save a lot of overhead on tables with very tons of lines. For the aggregation, there is a special type of aggregation we can implement in the built-in Postgres, which is the materialized views. We can create queries doing aggregation and store the results into tables. This is the principle of the materialized views. But they need to be refreshed. And timescale.db is able to refresh those tables automatically with continuous aggregate. This is the first level of aggregation. And the refresh happens incrementally on the chunk level. So you compute every aggregation by chunk. And if a chunk has been modified, you only compute this chunk for the aggregation. And so it's more efficient than just running the global query to build your materialized views. And there is the last one, the real-time aggregate, because the continuous aggregate has to be refreshed continuously from time to time, but the very latest data is not taken into this aggregation. So you can use real-time aggregate to have the most recent data into, but comes with a cost. And the last but not least, the job scheduling. Because every task should be automated. So if you want to implement a data retention or enable compression, you have to run it periodically. So there is a concept of jobs inside the timescale.db. And you can add your own with user-defined actions. I would like to speak about licenses, because this is kind of a sensible subject for the Postgres community. We are deeply inside the open source and the free and open source software, so licensing is a very important topic. So there are 2 editions. The first one is the Apache 2 edition with the free and open source code, and all the interesting stuff are still open source, but not free, as you can't, free as in freedom, as you can't do anything with it. The only restriction you can't do with this edition is to sell it as a database as a service. But here, we are a cloud provider. We don't sell timescale.db. We use it as an internal project. So it's fine. You can still use it, and it doesn't prevent us from using it. But if it's a problem for you, you can still use alternatives. There are plenty of them in the open source world. You can use PG time series, which is a recent extension. You can use PG Portman for job scheduling, PG cron, even cron jobs. You can use also the compression for only the columnar part. There are even extensions for that. So you can see Postgres is the most advanced open source database because they are also with the extensions. So the feedbacks. It all started in 2021. We wanted to rebuild our metrics platform. And by that, I mean we had this infrastructure with the servers we are running to create our services, scrapping or collecting data points, then sending them to a metrics backend. This is the big ellipse here, running on Word 10. Who knows Word 10 here? All right, nobody. As well as us, a lot of people running this infrastructure left the company. That happens, but also, and okay, more of that on the next slide. And we use Grafana dashboards to display the dashboards. And yes, the problems. The Warp 10 led to major downtimes, like multiple hours, which is unacceptable because of network issues, too much servers, and a failure, cascading errors and stuff, and even data loss, which is even more unacceptable. And there is also an issue on the client side where we have built an open source tool to talk every possible protocol to do metrics thing, which is a bad idea, of course. We wanted to make it simpler and do it one thing and one thing good. So the art, we have self-hosted solution on the left, software as a service on the right, with multiple collectors and backends. And you see there are tons of backends, and we decided to choose 2 of them based on Prometheus, which is kind of a standard right now. And we wanted to benchmark both solutions. And in the 2 solutions, we choose TimescaleDB. Because we know Postgres. All right, if we are able to run Postgres to make our company stable from the database point of view, why not using it also for storing metrics and for everything? And this solution is based on a standard, Prometheus, and there is no single point of failure. And it's also important to use the push mode here because we want to add a new service or to replace our existing service, not to be included inside the existing infrastructure. We want our existing infrastructure to not have so much changes, to be transparent. So we come up with this benchmark based on a distributed TimescaleDB running with a proxy in front of them, which is called PromScale, that translates queries from PromQL to SQL. Then we had to use Prometheus agents for scrapping metrics and all of that, and display them with Grafana. So the proof of concept has been created using Terraform and Ansible, and we decided to open source this code base. So if you want to create an infrastructure for proof of concept, you can take this as an example because there is no dependency with any existing infrastructure. It's just a disposable proof of concept you can run on your own. Okay, you have to upgrade it because, 2021, but it's a good example. We found out that the performance was a major point was on the data node for the I/O performance. So there are a lot major write workload. We decided to, okay, we have a big workload, let's do it big and raise the maxwell size to the roof and see what happens. So, no, it's not very effective. Do not do that. It's only, it implies the checkpoints, as described this morning. The checkpoints will flush the dirty buffers into the data files, will take much more data and much more time when this is triggered. And when it's triggered, it's like unusable with this amount of time. So please do not raise it too much. And also the disk space was an issue. Like in 24 hours, we fill up the disk space. So what happens? Okay, we see the documentation of timescale.db. Let's raise the max background workers. Oh, okay, we have this amount of cores. Okay, we just, no, it's only one per database. And in fact, it didn't even compress the existing chunks at that time. And we'll see later why. So in the end, the benchmark was not very okay. We ended up by, we have opened several issues at that time because we wanted to contribute to bug report, but we were not meeting the requirements and we decided to use Cortex, which is now Mimir, to create our new metrics platform. And it still runs today. And a side note, today in 2024, the multi-node support for timescale.db has been deprecated and PromScale too. So maybe it was a good move, but not really intended. And 2 years later, so keep that in mind, we didn't have a great image of timescale.db until 2 years later when we decided to use, we had multiple teams, no, not multiple, one team in particular, running a big service, coming to the DBA desk and says, okay, we have a Zabbix deployment and we want to store Zabbix metrics inside our internal service, database as a service. Okay, why not? So Zabbix is a monitoring system that can check regularly your infrastructure and send alerts, and pretty much like Negios. And there are multiple history tables with, for one, billions of rows. It's a snapshot of March, last March. So when you have 1 terabyte of data into one table, you can see some serious issues, even if you have decent hardware, because we have full NVMEs, 200 gigabytes. It should be great, but not that great. We identified that from time to time there are massive delete operations happening by spikes, like 20K deletes per second for time to time, like every hour or so. And from that time, the performance was degraded. It's called a housekeeper in Zabbix. It only deletes the oldest rows to ensure the data retentions. So the query is a simple delete based on the time. Okay. And fortunately, Zabbix is able to use timescale.db to solve this problem. But in fact, it's an opt-in solution. It's not enabled by default. So we can use it and enable it afterwards by creating iptables and updating the Zabbix configuration to make it, okay, now you are timescale.db aware, let's do the housekeeping with it. So now it's only a drop chunks function, which is pretty much like drop the partitions. It's way efficient to drop a partition rather than doing a big delete inside a very big table. And at the end, if we graph the number of deletes, there is pretty much no deletes anymore. Problem solved. But okay, have you seen this option just before? You can migrate data for existing tables. But this operation is very slow, very heavy. And by slow, it could take hours, days, only for 100 gigabytes, even with big hardware. So at this point, we wanted to move the database and collocate them together. Okay, there is this cluster. It runs on timescale DB databases. Let's move all the timescale DB databases there because there's a lot of noise. Okay, we want to move there. And what if we can enable on the fly the hyper tables? So we do it all at once. For that, we can't use logical replication for that because on one side you don't have timescale DB, and on the other side you have timescale DB. And by replicating the logical events, decoding the wall, you will decode the main table instead of writing into the chunks directly. It's not really compatible, and it's written in the documentation. So we ended up by recreating empty hypertables, using copy to copy rows with certain condition multiple times. And when we are ready, we just stop the application, copy the latest rows, and restore the regular tables of Zabbix, then enable timescale DB inside the databases for Zabbix to use the timescale DB and start the application. And now we can remove the previous database, burn it down, and it's migrated. And once again, next problem. We did have this space issue. At that time, the rate was increasing, not as crazy as before, but you can see there is like 400 gigabytes in a couple of days. That's not so much, but it's always increasing, kind of scary. Turns out we didn't have configure compression correctly. So for compression to work, you need to enable compression by doing an alter table, and you have to grant the login privilege to the user doing the compression. And for us, it's not a user, it's a role, because we delegate the DDLs to a role which is not allowed to connect. So we had a trick for that. We grant login, but we set connection limit to 0. So you can't connect in reality. But it makes timescale DB happy, so everyone is happy. And you have to also schedule a compression job and configure and start background workers. Because from time to time, the background workers can be stopped or fail, and they are not started. So right now, by enabling the compression, we had these drops of this space because the compression has been triggered here, and oh, this is a nice curve. And what about doing some skates over there? I'm a huge skateboard fan, so problem solved. And I/O. Okay, this time let's do it a little bit lower. And we just have raised the max wall size to 10 gigabytes, and we don't have those. Those were the IOPS, 3K IOPS all the time. And now the disk can take a deep breath and do some other interesting stuff. Problem solved too. You also have to keep watching the timescale.db version and ensure that Zabbix is compatible too, because generally Zabbix is kind of lagging behind the version of timescale.db, and we had upgraded too early for one of the databases, and the check has just failed, so the Zabbix was down. So please take care of the versions, or wait a little bit before upgrading. It will be okay. In a few days, it will be okay. So conclusion for Zabbix. You should enable timescale.db from the beginning before writing the data points. You should, but it's okay if you do this. Afterwards, it will be just a little bit more complicated. You can ensure your background workers are started, you prepare for high I/O workloads, and install supported versions. Okay, so right now we are a little bit more confident with timescale.db. We have a better experience, we have some knowledge, so why not creating our own solution based on timescale.db? And by that, what's the most critical part of a cloud provider or a business is the billing system. We want to make money, okay? We just have to live somewhere. So billing system. And my company has the cloud in the name, but we were before the cloud was even invented. So before we used to loop over the customers and the services. We looked over the price, so double loop, and create bills. It's called a subscription system. And we do it once every month. Okay, so what happened every first day of the month? Everything is on fire because you get to check this and every database. Because of course, there is no central point for doing billing system. Every service is doing it on its own. So we have to grab everything everywhere. But with cloud computing, there is more elasticity. A service can be started at the beginning of the month and stop it 1 hour later and recreate it just after and stop it 2 days later. You can create stop. So, what happens? And we want to make the customer, to make them pay for what they really use, to be fair. It's called a consumption system. So the requirement for creating such system for our company was to store consumption metrics somewhere, perform some aggregates regularly, and be able to write old data points, which is important because some units can send them after because they were broken in some way in this system. So, or they missed out some data and they want to resend them in the past. And most of the time series management system today disable this feature. It's only an append only. You can't write from the past. But fortunately for us, timescale.db is compatible with this feature. So we decided to go with this infrastructure where each unit will send their data points hourly, so every hour, store them in a queue, so we queue them, so we can consume them and send them to a very big database for storing raw events. We call it mediation, but it's a very big database. And there is a partition by event timestamp. So when the event happened is the partition key here. And we decided to create another smaller database, also based on timescale.db, called rating, where we will rate the metrics and create the bills in the end. And this time it's partitioned by the rating timestamp, not the event, only the time where the bill has been created. And because we want to crawl the past, we have to track the evolution of price, the catalog, the service prices based on timestamp, and we have a regular Postgres database we call catalog. So we can know at that point of time which price it was. So mediation, it stores raw events, and it computes daily aggregates. There is 18 million of rows every day in this table. And there is a lot of event happening here, and we have a chunks of 1 day. And we compress them after 6 months, so it's uncompressed for a long period of time, and the last time we drop it after 7 months. And the aggregation is regular aggregation. Okay, it seems scary, but it's only minimum, average, maximum, and a count of number of events, and we group by the time, the customer, and the subscription. Classic. So for that, we use continuous aggregates. So we can compute this every hour or regularly. And so when we want to query the data, it's right there. We have 2 policies. So why 2 and not why only not for refreshing the aggregates? Because, as I said, we can write data from the past. And if you touch only 1 row in a chunk, you have to recompute the entire chunk. So if you, or up until this chunk. So if you have serious batches from the past, it can hammer down the database at the compute time. So because we were, you can define the continuous, the time span for the computation, and this is the variable here. We start with every hour we only compute for 7 days, and every day we compute for 2 months. Because we were doing the 6 months every hour, and it didn't work very well until we found out. And there is a limitation. We can only schedule 1 refresh, so we use user-defined function to create another refresh with a different schedule. Okay, so continuous aggregates, as we said, it's a materialized view. We refresh policies, store in a materialized hypertable. So okay, it's a partition table. But we decided to use real-time aggregates. So you can alter the materialized view and enable the feature by doing materialize only equal false. And it shifts a little bit. You still have your main table, your materialized views, and a view on top of that doing a union between both. So now you have all the data in real time. But this operation can be expensive. This one is okay. So the rating, okay, even it's the second database when we create billing system, bills. Even if it's smaller, we had some challenges with this database because there is 122 million of rows in this table uncompressed and 3 billion of rows compressed after 3 days in 2 separate tables. Okay, the same chunk, same retention. And at some point we decided, oh, we made a mistake. We have forgotten to add a primary key, not a real primary key. We decided that there is a unique key in the table, but the unique key doesn't fit the requirement anymore because it's not that unique across all the units. So let's create one and solve the problem. Okay, let's add a simple ID column. Let's do a big serial and not null. boom. Oh, you cannot add a column with non-constant default expression. Okay, we need to find another, because there is compression, we have to find another way. So 3 billions of rows. Let's try another solution. We decompress the chunks, add the column, and compress the chunks. Easy algorithm. Oh, we fill the disks. Okay, because we decompressed everything before. So another try, do it more sequentially by creating, by decompressing chunks and do it in a running way. And it was okay. It took several days, even weeks, to do that. So yeah. And a little tip about compression. You have to choose what's called a segment. It's a column or multiple columns inside, I think it's one column, I'm not sure, but at least one column, that you do group rows together. You should segment by natural data, the data that correlate together. Not too high cardinality, not too low, and a good batch is 1,000 tuples. And I'll take the example for the very high cardinality, because that's what happens when we were compressing the chunks. We saw that the disk wasn't really going down, it was just the same and even more. It was only because the segment. So here we have a table, 2 same timestamps, so you can group by the timestamp. We have a unique ID, and 1 subscription, 2, and the quantity. With a very high cardinality, you end up with the same table with even an overhead. But if you compress by the subscription, for example, you can have multiple time and for the same time and compress more, which is better. So okay, right now we don't have any more a big workload at the beginning of the month. We can even more, we can predict what will be built for the next month based on this trend. So this was my real feedback. So what can we do? So with all the different projects, we have seen various issues or things that we should take care of is the version management. Because TimescaleDB is very active, you have to follow the upgrades. And when we started, there were a ton of segmentation faults. And using Postgres, you're not used to having those segmentation faults. And it's because it was triggered by the extension, but fortunately over time, those was reduced and we don't have them anymore. But because we have upgraded the extension. And how to upgrade? Always read the changelogs, because there are some operations you have to do sometimes, like rebuild aggregates. But it's very rare. You can update the package, the extension, and then you have to alter the extension and update it. But with TimescaleDB, you have to use the -x, which means don't load any query before returning the CLI. Because there is a loader, and the loader doesn't like to be loaded before the extension is being upgraded. Or you can use Ansible to automate the upgrade, and I've patched this module to make it reconnect just before the update, because we have seen that it's easy to use PSQL, but when you automate things, it's much harder. So right now, Ansible is patched. And sometimes you need to restart. It doesn't happen every time, but sometimes you have to restore. It's written, so follow the recommendation and restore. So, tooling. With this experience, we have created some tools to make our DBA's life easier, and maybe yours too. So we decided to create an Nagios plugin, but in reality, it's just a simple script, so you can run it on your own, and even it's able to check if background workers are started, and if jobs have errors, or if the version is up to date. And it's open source. So you can go on the link, you even can contribute, and it's really important for me because I like to contribute to the open source, and it's a way for me to do this. It looks like this in our production system. Everything is fine, everything is green, but if it's not green, you have an alert and you can go and fix. So what's next? There are some Zabbix deployments. We know they are not in our databases. So we want to include them into our internal service, so they will be able to use TimescaleDB, and they will have the same knowledge and same experience as we have, instead of recreating the service on their own. Same with the billing units. We still have the old system in place. So when I say it's not on fire every start of the month, kind of lie, but it's not a big lie. It's a small workload. So we have to migrate the remaining units. And we have a change data capture platform based on Debezium and Kafka to create our data lake and our data warehouse. So we might plug this change data capture system with TimescaleDB. In fact, we already started with that. So the takeaways. When you run TimescaleDB at this scale, or even your scale, be prepared for high I/O workloads. Ensure everything is properly configured from the start. Yeah, it's hard if you don't know the product or the service extension, but it's better. And moving large live data sets is always challenging. So first, I would like to thank my colleagues. They might see me on the stream, so hello. And of course, Timescale, the company, because this software is the reason I have given this talk today. So I wouldn't have been here if Timescale wasn't maintaining this extension, this product. And the most important, you for being here and being part of the Postgres community, because it's a brilliant and vibrant community, and I'm in love with this community. So thank you. If you have questions.
Brilliant. Thank you very much. I've got the red one. Thank you. No? Yes. First try. Thank you very much. Also for you, a very nice elephant. And I think we have time for one question only.
Thank you.
I get to ask another question. Excellent. Okay, so very nice demo about why the Timescale DB plugs a number of holes with Zabbix. I'm not a Zabbix expert. I have used it. I've not had problems with it with the volumes of data, which you do. But I did think, oh, surely Zabbix needs to implement partitioning so they're not doing massive deletes every 20 minutes or every hour. Did you feed that back to the Zabbix project? Because it's great that time series plasters over the cracks, but Zabbix should get better.
So implementing native partitioning instead of TimescaleDB in Zabbix?
I think any partitioning, then you just will fix that problem.
I'm not that much in Zabbix contribution too. I just install I'm not even installing Zabbix. I'm on the database part, but maybe, yes, it will be a great feature for them. But other than that, storing metrics inside the database with Zabbix might not be a good idea because in our case, we already have a metric system. So why not use it? They use their own Postgres databases for their own implementation of their own Zabbix. So, and of course, my team is not using Zabbix for monitoring the system. So we have very software for doing the same thing. We should use the same thing, and by removing Zabbix, for example, or choosing the metric system, we remove the problem. So to improve Zabbix, that would be a great idea, but not implemented at our own company.
Yeah. Okay, thank you very much.
You're welcome. Thank you.
Oh, no, no, no. My chances of the Lego sets are getting smaller and smaller. This is no good. Okay, last speaker of today is Hedy. I know Hedy for 2 years now as this small person from Chicago. I'm always surprised by the amount of energy she brings. I always feel like she organizes Chicago on her own, and I still have plenty of energy to do enough stuff where most people, or you need at least 3 people to do this amount of things. But this time she's not talking about how to organize events, but about log analysis. So, have fun.
Right. Thank you. And why I do not see me under the, oh, okay, it's coming. No? Yeah. Yes, no? Okay. It worked. It just worked. What happened?
I know it worked. I've seen it working.
I know. So what's the problem? And I do not have any backup. No, it's all fine. That's what I'm saying. HDMI is fine. It's not. It's not. Okay, super. Thank you so much. And where is it? Where is it actually? Nah. Okay. We are here. Okay. All right. Are we coming? No. Yes. No. No. Yes. No.
Just wait.
Patience is not my virtue. You know me long enough for 2 years.
Yes. Is something happening?
All right, something happening. Too slow for me. Happening. What's wrong?
Yes.
All right. Hey, all right. Okay, beautiful. Amazing. So we are finally in business. All right. So good late afternoon, everybody. Thank you for okay, no, it's not going. Okay. Yes. Shoot. No, it doesn't like me. Okay, hold on. Okay. All right. So thank you for sticking here, because you know what? That's I think second time I am the last presenter, and first time was when I presented at Postgres conference for the first time. So yeah, and so when I asked actually Boris why I'm the last, you're like, okay, you can handle the last one. So now I have this challenge that I actually need to handle it, okay? So, and you know what is difficult? If the other talks would be boring, that would be one problem, but we had so many amazing talks today that I do not know how I can actually keep up with them. They're like really, really amazing. So I will give it a try, and I will try to be on time. All right, and I do not know why I'm so blinking, and I don't know who can do something with this because it's keeping not liking me, actually. Okay, any idea? I know, okay. So, hold on, okay. And now it does not like me here either, actually. Oh, this one you think? I can switch ports, actually. Maybe that's a port, no? Okay, okay. And can we also get this thingy, because otherwise I won't be able to click. Better, worse, same? Okay, now I need to make sure it's not mirroring also. It's another one. No, it's, oh, no, great, okay, yes, it's great. And can I, oh, you think I will be able to do this one? Okay, hold on. Here, and, okay. All right, beautiful. Okay, working. All right. Okay, so I'm Hetty Dambrovska. I work as the data architect at DRW Holdings. It's an international company. We have offices everywhere, including London, including Amsterdam, but I am in Chicago office. And my other job, which I actually hold, while I had 5 different day jobs, I'm a local organizer of Chicago PostgreSQL user group. So I've been there for quite a while, as I mentioned. So I always like good speakers. So if you happen to be in Chicago, let me know, and not the last minute, okay? I will be happy to have you as a speaker. And we always have pizza and beer. And also, I'm a local organizer of PGDay Chicago. So we had 2023, 2024, and I really hope we have 2025 and going. So once again, if you are interested in help me, let me know. Okay, so what's next? So talk about PG Badger. Why and why we love it? Let's start from why we love PG Badgers. So first question, anybody here never used PG Badger? Hands? Okay, there are some. Okay, who did use PG Badger? Yeah, all right. So if you did not use PG Badger, you either do not support anything in production or you just do not know that you should use PG Badger. It's like absolutely amazing tool because what it allows you to do, it allows you to see what's going on in the database. It produces tons of reports. So you need to turn logging on, by the way, like log mean duration 0, but when you do this, it tells you everything what's going on. So to give you example of like traditional PG Badger, because we will tell in a moment what was missing, but like traditional PG Badger report looks like this. That's the first page. So here you can see that, okay, so we recorded from this moment to this moment, we had that much traffic. We had, we know what were the fastest queries, what was average query execution, your read traffic, your write traffic, all lots of valuable information. And also, what is more important, you have details about your queries. And not only what was running the longest, but things like, okay, which query was cumulatively the longest, maybe relatively short query, but runs most often, so take most times, what are like normalized those queries, lots of other valuable information. So as I said, if you did not use it, like start using it. Honestly, like you would not regret. Again, we love it, we use it. I used it, I think, like for more than 10 years, like from very, very early versions, in all the companies where I worked and I used Postgres. What is missing, or rather was missing, because we fixed it, but I don't know whether anybody, like, used it like me very often. What you were missing? Anybody? Yes. What did you miss? What is? Flexibility, okay, yeah. Flexibility, that's right. And I can tell what exactly I was missing, but that's kind of relates to flexibility. I wanted to be able to see what individual session is doing. Because, for example, you have this situation, okay? You have most frequent queries, and you have like a lot of commits and begins, and since you do not have enough inserts and updates, you kind of suspect somebody is doing some ORM, is doing something not exactly right. But you cannot tell it to developers because you come, no, I don't know where you found it. I don't know, it's not me. So I always wanted to, okay, that's you, and that's what you've been doing for 10 minutes. And I was not able to do this, and I was trying all monitoring tools in the universe. I talked to developers. I tried to do it with Datadog. I tried to do it with New Relic. New Relic actually is very deceiving because they say they record everything. Actually, they are sampling. And you can see some of them, but you cannot see this session which you need. So I was kind of like desperate, because I really, really need it. I need to put it in the developer's face. I love developers. I love working with developers, but sometimes you just need, yeah, go fix it, right? Okay, you know, my favorite phrase, I know it's kind of in Floor's books, I think, right? What developers say? Everything works fine until application hits database, right? So database is a problem. So we always need to do otherwise, to prove otherwise. So I was like, okay. So I knew there should be an answer. So I kept trying, searching for the tools, and just ask what to do. So my thought, okay, so if we do actually log mean duration 0, technically speaking, we have everything. But who tried to search for these PID in logs? Somebody tried, right? Because you are desperate. And you know how long it takes. And yeah. So what can be? How can I just take this log and map it to the database? And you think it's easy, it's not. So actually, I found a log4 in data wrap. I thought, oh, okay, this will do it. This will map my log to the database. I tried it, installed it. No, it actually does not parse anything in the statement. So you cannot do much with this. It's just your time stamp PID, and that's it. What I'm going to do? So I need to parse, and like, okay, actually, PGDay parses the log records before it creates its summary report. So how about I will take this parsing? That was a brilliant idea. And then I asked, okay, so I cannot steal parsing from PGDay. I need to ask nicely. So I asked, let me say, can you introduce me to Jill Zerald? And she's like, yeah, but you know what? He's so shy. He might not want to talk to you. Give it a try. So she like message, okay, hey Jill, that's Hetty. Hey Hetty, the Jill said, oh yeah, Hetty, nice. I was like looking forward to meet you. And I like, okay, Jill, I want to do this thing. And you're like, I can provide you any extra reports. I'm like, no. I do not want your extra reports. I want to report myself. Can you give me raw output? And he went silent for a week. And like, oh my gosh, what did I say wrong? I offended him. He like didn't. And in a week, he like, hey, check this last commit. Like, eee. So we actually got it. And then there was a month of very intense debugging because I tried and I said, oh, this does not work. Then we like discovered corner cases. So people who are following PGDay on GitHub they started to message, Hetty, what are you doing? But then finally, we got our PGDay magic, which I'm ready to introduce. So the rest of the talk. So we will look at the changes which were made to PGDay and how we can use them, how we can automate log processing, how we can actually use it for things, and what does it take in terms of resources, and what we want to do next. So first of all, new PGDay features. Actually, there were 2 features. You know what? When they came live, what I started to see on social media, oh, I never knew PGDay has this. It's so cool. Like, yeah, he didn't have it a month ago. Now, yay, here you are. So there are actually 2 new options. One option, dump raw CSV. So what it does, instead of producing HTML, it does produce, but it's empty. You can direct this output into CSV file, and it will actually like give you the CSV of this log. And the other important thing is log separator, because by default is comma. Comma is not really helpful when you parse logs. So what I usually do, I do log separator #, which kind of like the safest, let's say, not without an errors. And then you produce CSV log, which you can do what? All right, now you can load it in Postgres. And now, so look what happens. So that's your log, right? And yeah, Leticia tried to search in this log and this PID. But now, instead of this file, you see that. And what you can do now, you can do select. And you can do it select whatever you want. Find whatever you want, do any analytics you want. So that is quite amazing. So thank you, Gilles, again. I know he didn't want to do stuff with me, but I'm still immensely thankful to him. All right. So what we can do with this table now, which is not just a log, it's a table. So several usages. So first of all, as I said, session tracing. Now we can here develop it. That's what you are doing. Then you can trace events which happen at the same time, concurrently, which is very difficult with log. You can query, while this was slow, what else was going on? So you can do this once. Then you can do performance dynamics, not only like in summary reports, mean, max, average, but actually, so all of these things. You can do whatever you want, analytics. And another thing which is not so obvious, but in my firm, it's actually very important usage, precise access control, because now you can not only trace who logged on and from where, but also which tables they access and what they queried and what they did. So it's like a very precise security control. So now design details. I'm cautious of time. So I talk fast, sorry. Stop me if too fast. Also, you know what? I'm the last. You won't have time to corner me in the hallway, so now I need to leave time for questions, right? OK, so design details. So yes, it's CSV, and it's obvious table structure. But there's several things which are not so obvious. So first of all, log ID. So when I said on Wednesday, I presented the same talk in London, so there was a question, why you need unique ID? Because if you have session ID and you have the line in session, you get uniqueness. That is correct. But what you do not get the preserved order of records in the log. Because look at the log. Again, it wasn't one of the previous slides. By the way, I actually uploaded the slides. I've been good. I uploaded the slides, so you can follow me from the conference scheduler. The only way you can actually know what happened after was the sequence of lines is to literally record the sequence of lines in the log, because you can have hundreds of events happening at the same milliseconds. So first was that's why we need log ID. So my first naive solution was, OK, I define big serial, and I load it, and just go on. Then the second question, partitioning. So the log is growing. So again, I needed to have some generalization. My first approach to partitioning was partition by its horrible name. I might change it. I did not open source it yet, but it's called log sample time. But actually, that's the day. So logs are partitioned by day because we actually hope that we can archive them by day. We do not need them after some time, maybe. And then what were the problems? So one obvious problem, what is wrong with big serial? Oopsies, we lost one log file. And now everything is enumerated improperly. You cannot catch up. You cannot, oh my gosh. So what you need to do, you need to drop the whole partition, find a place where you missed it, and reload it again. So not cool. We do not want it, especially with some very large loads. So then what we decided, so even if we do this one, so that's what Miss Van Dok. So then what we, sorry? OK, what we decided, OK. So then the other thing is, if even we reload, how we can make sure we do not duplicate, because that was the other thing. So we wanted to make sure we can reload missing file, and we do not want to duplicate. So what we came up with, we decided to partition it even further. So each day is partitioned by log timestamp. And how we calculate log timestamp? We take the time log was created, make an epoch, round it to the nearest integer, because it's unlikely we will create several logs in 1 second. And that is our partition. So that is like partition by log timestamp. So now life is relatively easy because we can drop this partition and insert. And remember with log ID, so now we drop the idea of big serial and we build the log ID. So how we build it? We do this timestamp, multiply by 10 to the 9th power, and then we add the sequential number with this log. So what we have this way, first of all, it's 100% reloadable, and we always preserve the order. And even if we need to drop, oops, okay, there was an error with this file, we need to reload it, so we'll still get the right order, and everything is pretty solid. So that's my small but important design ideas. So then, next one, indexing. What indices we need? So obvious index, obviously primary key, which is what we need for partitions, and log ID. Obvious non-index, and why I'm saying this, because when we gave users the permission to query this, like, can you build index by the username? Nope. You know why, right? Everybody here knows why. But I was like, okay, no, we're not building no username, no client name. And then I kind of explained why you do not need it. You can just query these intervals and find all the users. But then another interesting thing, you want to query by query, right? And query is gigantic. And you do not know it's uppercase, lowercase. You cannot really build like B-tree on it, so you want to build pattern search by query. And when I tried it first time, Postgres said, I cannot do it. It's like too big, right? So the compromise we achieved with Postgres, that's the index I'm building. So it's a pattern search by lower first 1,000 characters of query. So anybody else uses pattern search indexes except for me, because I love pattern search. Okay. Thank you, Leticia. So I love it. It's super useful when you want to do like queries. And so that users would not go into trouble, because no sane user will write this. I generate search functions which have this built in. So the user actually gives me what they want to search for, and I transform it to this query. Okay, so now, next thing, security. I'm not giving talk for security because nobody likes my security talk, but I have to mention. I have to mention, right? So I apply like one of my 4 security models, and we give each of our, so we have lots of internal customers in my firm, so each customer has their schema, they have read-only user, and so each log is a separate partition table, so they can use it. And for monitoring, we have a couple of monitoring tables, so which monitor the partitions which were created and files which were loaded, so we also kind of can backtrace what we were doing. Now, examples of how we use it. Now, yeah. So first is tracing application. So same log, right? Like 100,000 begins, 100,000 commits, and we kind of think we know, but they do not want to admit. Some queries, what I'm doing with this log. So I'm selecting the processes, count the number of begins, and sort by the winners, okay? It's my results. Okay. So there are champion processes which have like 5,500 begins in one session. And what I'm doing then, I take this PID, because now I know who is the winner, and I query them, and that's what I get. Okay? So what we're doing here? Begin, select, commit, begin, select, commit, begin, select, commit, and 5,000 times. And obviously, that's our friend ORM, and even this ORM even has name. Who knows who does it? Huh? SQL Alchemy. Yeah. So just they do not have the like legit way to suppress, read all the transactions. So our friend Alicia Kucharczyk recently found the way to fool SQL Alchemy, but like technically that's what they do. So gave it to the user. They said, oh my God, okay, we need to do something. So they went away thinking, but at least, I can tell. And also, by the way, this particular customer was super concerned about their performance. And they can even see how much each begin commit cost. It costs something very small, but it does. So it slows down in addition to creating all the other problems. So that's relatively easy, and I was suspecting this. So case number 2. And here I can relate to a couple of previous talks which were given today. When something was fast and then it becomes slow, that is like, we do not like it, but at least the usual suspects which we can check, okay? But I hate when customer comes and said, sometimes this is slow. Like, what are these sometimes when it's slow? Like, at the end of the day, early in the morning, every Sunday, every Friday, first, sometimes slow, like sometimes. So I kind of put this trap, start doing full logging and tell me when it will happen. I did for this customer, I did it a couple of times. Then they said, okay, yeah, this night. I did previous logging 3 days before, and that was like all good, all fine. Oh, they said it good. I actually did not think it's good, because it runs like okay, it runs like 40 minutes each load, maybe too much, but sometimes it's really, really slow. So just to skip a couple of things. So I found it, I know it might be small, like my slides are there, okay? I started from looking for the slowest query, and I found that the slowest query was create index, okay? And I've started to look, so August 14, it was okay. August 17, it was very slow. So that was first, it was slow between midnight and 5 a.m. So, okay, how this was executed between midnight and 5 a.m. So here you can see that it was executed like every 8 minutes of each hour, and it was kind of like consistent time. So same story, I'm querying it for the August 17th. And what I see here, you see the 2 a.m. it started way, way later. So now you can see something happened, and it actually went so late that it blocked the next execution. So there were 5 here and 4 here. Like, okay, all right. And this now, it's like, first of all, if this index is rebuilt 5 times during the load, something is definitely wrong. But now also it's like something was horribly wrong on the 17th. But now we know our PID, and now we can see what this PID is doing. And we know the good PID, good kind of, sort of. So what we're doing here, we are querying this good PID, and we see what it's doing. By the way, again, begin commit, but at least now it makes some sense. Some, right? So we're doing drop index, drop constraint. Who knows why they're doing this? By the way, any ideas why they're doing this? 5 times a night. Any ideas? What they were doing? Loads, yeah. They were doing loads. Now why they were doing this, and I just have a statement to make. Because still, not 30 years ago when I was a student, not like 20 years ago, but even now, all the textbooks about databases tell them before the bulk load, drop all indices, drop all constraints, then do load, and then build. And no matter what is this mass load, you might have like 100 million rows table, and you load 100,000, they still would drop, build. who knows how long it takes to rebuild the index on 100 million rows? Okay. But they were taught like this, and that's so they come and they do this. And by the way, here, they dropped it before they figured out whether they need to load or they do not need to load. So just in case, because that's their process. So, but okay, here is like normal execution time, sort of. Okay? Now, what was happening on the 17th, you see all of a sudden, drop the same index takes like 5 times longer. And by the way, you see commit takes longer. Everything starts to take longer. So what's going on? And I add on this drop foreign key constraint. Because we do not run in this problem often, but I had it in my history of my relationship with Postgres, so that is a problem. And the problem is that when you deal with foreign keys, the log which is put on the parent table is actually more kind of like serious than all the other logs you put during the process of insert and update and everything. And I started to search because documentation is silent about it. So, but I knew there was a problem. I started to search, and I found that one of the mailing lists. So, hi, why when I drop foreign key, it puts exclusive log on the table, on the parent table? And you know the answer, because how foreign keys are implemented in Postgres? Triggers, internal triggers, and both on parent table and on child table. So when we draw foreign key constraint, it's DDL, and because it's drop trigger, and that's exclusive log on the parent table. And what happened here? That all of the slots had one foreign key, which in the parent table was a table which had the files IDs to be loaded. And each time before the load, they needed to verify that it was loaded without any issues, that they have some data to load. So I said, and begin commit, right? Also. So, and begin commit for reads as well. So then I decided, okay, so now this other feature, because you can see what was going on simultaneously at the same time with the same period. So here is my query. I actually looked at this table, which happened to be parent table, and that's what I saw. And you see there are multiple PIDs. They are doing pretty much at the same time. Alter, drop, create, query, and all begin commits. So waiting. So I show this to the end user, to the customer. Is that, yeah, that's how a standard injection process works. That's what we do. Like, okay, developer, go and deal with that. I showed you what the problem is. So I was pretty happy with this solution. So now, it's all good, but now how we actually are setting this up. So, some people in Postgres community do not like me because I use too many functions and storage procedures. We are not pointing, we are not blaming Magnus, but so I actually think it's good because at least then I know what people are executing. I'm responsible for this. I maintain this code and I know they will do what I tell them to do. So I have several functions to create this schema for a new customer, to create the log, to create partitions, start loading, so everything is like pretty much automated. But that was not enough, because some people know where I work and how I work, and we have like we have way too many internal customers. We have over 200 production databases. We have like less than 2 people supporting them. And when people are, oh, we want logging, we need logging. So we need to have everything completely standardized, completely automated. So we did some brainstorming. And one of my fellow DBAs created the script which does everything. So for the script, we pass what is the name of the server where we process these logs. What is the host name and port for the customer who we want to process. What will be, is it a new customer? When we want to start, whether we want to run for specific time or we want to run it as a daemon indefinitely. And this script checks everything and does everything. It would call creating new customer and create a schema. It will call creating a new partition table. It will call creating partition. It will replace partition, and so on and so on and so on. If we try to reload partition at the same time, the same partition, it will be automatically dropped and recreated. Now, by the numbers, because one of the things, for several years I was, how I would put it politely, arguing with people because like, no, you do not do log min duration 0, it will slow down your system. No, it does not. But then it will take so much space. It will take so much space. Sometimes, some of our internal customers, I can tell you why we are not doing it permanently for everybody. We have some created customers which generate more than 100 gigabytes of log every hour. So I'm not doing this. But we do like this spot tracing, and sometimes we enable continuous logging for the customers which have like reasonably sized logs. By the numbers. So this log, which I just showed, so it was obviously all my logs should be chocolate and ice cream, but that was actually modeled from the real log. So the log size was 2.2 gigabytes. That we logged 11 hours of work. It produced like 3.3 million rows, and table size was 1 gigabyte with this ginormous pattern search index. So actually that kind of compresses it. So the only problem you really need to take care of, that logs take space on the source system. So you need to make sure that you archive these files continuously. But other than that, it's all pretty reasonable. Now, what else? What are our next plans, future work? So first of all, I want to do more standardized reports because, again, users, when they figured out we can give it to them, like, yeah, want it. But you know what? Users are creative. So all of us know lots of ways how users can produce inefficient queries. So I am trying to create more standardized, not reports probably, but ways for them to query and to know what to do, not to do. I can remind as many times as I want, please address specific partition, but users are users, right? So that's my next goal. Then unit tests, and I try to do, if you ever saw my GitHub, I try really hard to do unit tests, so this is not PGDay covered, it's in my to-do list. So archiving strategy, that is something I've been advocating from the time I started it, and still use, no. So we actually need to develop standardized strategy, the same as we can enable it with one click, we also should enable archiving with one click. And the last one, you saw in my last example, I could only deduce that there were blocks, weights, but there was no indication. And that's something I actually want to talk to some people who are working on the recording weight events. Again, not pointing fingers, and I hope that I will be able to incorporate them. And actually, again, after I gave this presentation on Wednesday, there were questions, are you going to open source it? I hope I can, like a big part of this. Again, Jill's refused to work with me on this. But if anybody wants to work with me on kind of more productionizing, like packaging and everything, please reach out. I will be super happy. And reach out. So again, I'm Hetty. I'm everywhere on the internet. So like, find me anywhere. Ask me any questions. So we'll be happy to answer. Thank you so much. And I didn't time ahead of time.
Okay, thank you very much. Any questions?
So what's the problem with processing the direct PostgreSQL logs instead of getting it out of PGBadger? Why did you get it from PGBadger?
I do not get it from, I get it from PGBadger because I need parsing. So I did not want to create my parsing because I wanted to reuse the parsing that PGBadger used. There are like lots of things how they are parsed because it's not super obvious how to parse log. I did not want to write my parser. That's why I wanted to politely steal it from Gilles Darrelt.
So just logging it from Postgres as CSV and directly inserting that into Postgres is not...
no.
You need parsing as well.
More intelligent parsing, yeah.
Cool. Okay, thanks.
More questions? Yeah, over here. Boris, I have a question.
Oh, you have a question? Okay, go ahead.
No. All right, I will use this mic. Isn't the impact on the system pretty big? To load the systems back into the system?
Yeah.
Isn't it a pretty significant impact,
on
especially
what?
on the disks?
On which disk? No, we are loading to a different server. So loading does not have zero impact on performance, or maybe it's like negligible, even like maybe fractions of milliseconds, because log is the file, it's not the part of Postgres, so it's like logged and logged. And then we FTP these files to a separate server.
That makes a lot of sense.
Yeah,
I thought the same users have access, so it is the same database, which is
No, but that's what I'm saying. We have one centralized database, and we collect logs from all our 200.
Okay, thank you.
Thank you, Hetty. I'm also a huge PGBadger fan. So, certain sense of preaching to the converted, I really like where you're going with this. There was one bit I didn't follow. It's like no indexing on. Was it username or client?
Yes.
What is it like? Is it GPDR? Like, why not index those?
Because it's indexed with very high selectivity. Because even in the systems which use security and grants properly, and there are very few, even in these systems, you might have like, I do not know, like 20, 50 distinct users' IDs. So indexing by user ID does not make sense. It's like inefficient index. That's all I'm saying. Because for each value in B3, you will have like many thousands of matching records. So actually, Postgres most likely will ignore this index, but why bother? Why create extra volumes?
Okay, thank you very much. Any more questions? All right, then I think we are done with the talks for today.
Cool.
Thank you very much. Got a beautiful elephant for you.
Thanks so much.
You know how they work?
Wait, is magnetic or what is it?
No, you can't.
Oh, you do this, tell me.
I will not do it for you, but there's a pin. I only can do this with completely undressing, and then you can turn the switch on for the lights.
Oh, okay, but it's like magnetic, right? Or you need to pin it? Or need to pin
It's a
it
pin.
Okay, cool.
So I can only do it by...
All right, okay, got it. Thanks so much. Thank you. Okay, and where I'm leaving this one?
I don't know. Maybe you can throw them up? No, I think you have to bring them back.
Okay, you refuse to throw me off.
Did it help with that?
He's making fun because No, now you need to.
I will find one. The yellow one. Or the black one.
Got a yellow one.
All right. So, how's it been going during the day? Have you been having fun at the conference? Good. Excellent. Good. So, please raise your hand if you will come back for another edition of PGDay Lowlands. Oh, excellent, excellent. Who will come back if this would be in Friesland? Okay, who will come if it will be in Texel? Yeah. Okay, that's good. Who will come back if it is in Rotterdam? All right, good. Good. If we do a second edition, we definitely need support from you as a community, so please give all the feedback you can during the conference to the speakers, also to the conference itself, but also in social media. You get all the, I see laser works. And also, we want to thank all our sponsors once again because they help us really a lot. So please, thank you. We have Kangaroos, Optima Data, EDB, Cybertech, and Adyen as partner sponsors. Yeah, you saw them also at the booth. You also went to see them. You got your stamp from your passport for the sponsors, so which is there. We are going to raffle that. Was that a good idea or not to go and visit the sponsors? Yep. Yeah. Good. Excellent. That was not the only sponsor. We also have supporters, AWS, Nextteam, Percona, Microsoft PE experts, and UpCloud. So please thank them also as well. All right, good. Dirk, would you like to say a few words about the speakers? I know that you're one of the speakers. How was the experience being a speaker here at PGDay Lowlands?
Yeah, it's pretty good to speak here. I really like the venue. I'm pretty happy with it. Even though I have to admit, this is the very first day this year. I'm actually slightly cold. But maybe it's time to go for longer pants and a sweater.
You grew up too fast. That's the problem.
Maybe.
So, would you appreciate feedback from the audience in the website that we have, so you can get some feedback?
Feedback is the very best. In general, people are very shy to give feedback. If you want to give one person feedback and you're afraid they will get angry with you, then give me the feedback because I will never get angry. I'm always willing to learn. But I think actually most people and most speakers are willing to learn, so be kind, but try to give feedback where we can actually learn from. It really helps us to improve the talks.
Good. You are a speaker. Are you going to give feedback to the other speakers?
I always do.
Good.
At least if I see the talks, because I always skip the talk after my own talk.
Yeah, and the speakers can provide very good feedback to other speakers, so please do. Now, Bilge was asking how many female speakers do we have here in PGDay Lowlands, where you can count here 5 out of 14. That is roughly 35.71%. I mean, a campaign for all numbers are equal, although some numbers are more equal than others, but that's why we want to give that second level of precision. All right, good. So, give feedback to the speakers and also join the YouTube channel. Why should we join the YouTube channel, Dirk? Maybe your talk is going to be recorded and appear there afterwards, so that we can watch it
I was
again?
wondering, like, I want to say, like, oh, all the talks are on YouTube tomorrow and you can watch them back. But actually, I have no clue how long it takes us to get them on YouTube. But eventually, I think this is kind of eventual consistency.
Eventually, they are going to be there, but they are going to be there. So subscribe to the channel, and then you can see everything. Now, also, you can get feedback not just to the speakers, but also to the conference. So please go to the same website at an F for feedback at the end of the slash, and then you will be able to give us all the opportunities for improving this for the next year. Okay?
And also, if you have the perfect event space for next year, or this must go to city, or you're really in favor of Tessels, please let us know as well.
Yes, there is a place there where you can put your preference, okay? Now, some extra acknowledgement, because it's been an effort of everybody in the team and volunteers and everything. We would like to thank the technical team who is up there, doing a great job. Thank you, guys. Also, our photographer, Megan, who is going to show us some excellent pictures then later on. It's always risky to give acknowledgement because you always forget some people, but we already gave it some people in the beginning. So now we would like to have also the organizers, the program committee that is here, the COC committee, and the other volunteers, Paul and what was the other one that was not in the list? You see, this is the moment that you forget people. I didn't sleep enough even last night, so that's why my memory is kind of failing me. But please come here because we also want to thank you. We thank all the speakers with a nice elephant, an epic electronic elephant, so you also get one of those.
That's amazing.
So the people that couldn't be here from the program committee, they're also going to get one when we see them, because we don't have more budget for.
One. Chris, can I offer you?
Never seen these before.
You've never seen them before, I can imagine.
So this is the artwork of Chris, our high lowlander. So, so please give an applause to everybody who participated helping to make this conference. Okay,
Where's Rita?
thirsty, so.
Rita has been begging me for an elephant for the entire day.
Rita. You're also part
You're
of
part of the Code of Conduct Committee, so... There you go. Finally.
Right. Okay, thank you. You can go and sit now and then be ready for the social event. All right, good. So I told you that we had a testing challenge. So if you tested Postgres 17, you had the chance to get some prizes. We already gave one to Ed. Ed, are you there? Come, please, to the front. So he is now a contributor to Postgres because he tested incremental backups. And he's here just because he did it last week, and he was the one who won the prize for getting a free ticket to here. Okay?
And I'm now testing with the release candidate 1 as well.
Okay. Yeah, because you did beta 3, now you're doing?
With the release candidate 1.
Okay. Yeah. Thanks. Okay, but we have more prizes. So please, an applause for Ed, who made the effort for testing. Good. Thank you, Ed. So you can go and sit now. We have some beer for you later. And we need to do, well, what is, I had the book here. So we have two prizes, a book and an elephant.
We don't actually have the elephant here, I think. I think the elephant is in France at the moment. But if you win it and you happen to be in Athens, we can definitely take it to Athens. And otherwise, we will make sure it gets sent to you anyway.
Now, I did the raffle myself, and doing all the people who dared to do the testing, and there was a clear winner, because there was only one test that was submitted before 2 minutes to midnight, and that is Teresa and Dirk. So Teresa gets the book, Dirk gets the elephant. There you go. Okay, thank you, Teresa. Thank you, Dirk. Now, something very important. I saw that Pablo...
Can I say something about this?
Yes.
I think this is the very first thing I actually did with Postgres. And it's like when you're learning walking, right? It's really easy. Everybody can do it. But when you actually take your first steps, it's actually pretty cool to do it. It's not the biggest test ever we did, but I felt pretty proud and pretty cool to do it. So I encourage everybody, just take a go. It takes a little bit of effort to take your first baby steps, but the feeling is really good when you do it. Well, you know me, I like partitioning, so I try to test the most difficult partitioning thing, which I failed to do. And then we tested Robert Haase's function to see, it's from the wall files, you get a summary file, and you have a tool to see what blocks have changed in the summary file, and we tried to break it, and we didn't manage to break it.
Just, in a way, it's good. So, the important thing, I also tested it, but I didn't send the email on time, so I couldn't win my own book. What a shame. But I can still send the email, because if I do it before the official release of 17, I will appear in the wall of testers. So this is also important, because if you contribute, it's good that you appear somewhere, okay? So I saw Pablo, who was showing his demo with Postgres 17. Did you notice that he was using the Wordle game with 17? But he didn't send an email either. So Pablo, send an email, you will be in the world of test. Yeah, do it, okay? And Jonathan Gonzalez, who is somewhere there, he was showing yesterday in the meetup, he was testing with Cloud Native PG, Postgres 17, so he should also send an email. If you want to test it and appear on the wall of testers, we can show as a community, like the PGDay Lowlands, contributing to a new release with less bugs. If you find one. If you find one, I have another book, and I will give it to somebody who find a bug, and I will have a book for you, signed by Gianni Cioli. Okay? Good. So that's for the testing. Now we have a raffle for all the people who is here for the passport, but it's super difficult to take it from there, so we are going to do something different.
I'm really curious about the selection process. Right, if you open it, I will take one blindly.
And it's magic, they are gone.
No, they're not. I've got one.
Wait, what are we ruffling? The flowers or the metal fan?
I don't know, it's up to you. Flowers first.
Which one first? Flowers first, okay. Flowers first. If you're not, if the winner is not here, we raffle another one, okay?
All right, Alexis Shabrov. I'm really sorry for mispronouncing your name. Ah, too bad.
Too bad. That's too bad. Ooh, oh, no, he's there, he's there. Okay, okay, good, good, good. Please, a round of applause for the winner. Congratulations. Come next year, maybe you win again. Yeah. Okay,
we,
good.
Reshake it? I reshake and then you can pick one.
Okay, good. Teresa, you pick one.
Yeah, fine.
You can also lie about the name.
Boris no.
Yeah, yeah, yeah. So we have a Guy Giles. G. Oh my God, sorry. Name.
Giles.
G. Giles. Yes. Sorry for mispronouncing it.
Hey, congrats.
All right, what is the clicker? Here. Okay, so we have 2 winners of Lego. We have also winners for testing. Now we can all win in the social event. You can win more friends. You can win some drinks. And we can all win until 21 hours, how is it? 9 p.m. Or if we run out of budget and there are no more drinks, whatever happens first. So, yes. So the social event is going to happen in Rotterdam. It's going to happen. We had that idea, actually. We discussed it in one of the meetings. If you see the picture again with the video, and then when everybody's smiling, is what I propose that, and everybody like, no, don't do that. Right, so it is here, actually. So you don't have to go anywhere. And then we will see, when we discuss some ideas, and we do a post-social event somewhere in Amsterdam. Okay, so this was it. Thank you very much for coming, and we see you next event. We don't know when it's going to be or where. So thank you very much.
Thank you very much.